Test. Oh, thank you. Hello, everyone. Thank you for joining me this afternoon. I'm very excited to be able to kick off our awesome set of speakers on the Build platform. Can I get a show of hands? Is it anyone's first East Coast RepRap Festival? Oh my gosh, almost the entire room. That's incredible. It's been since 2019 that we've been able to have this event. I was lucky enough to be there just a few years ago. I wasn't speaking then. I have prepared a very full presentation for you all today, so I think I'm going to use all of my time. If I don't, I'm happy to take questions at the end. If not, you're welcome to stop by the PowerBelt 3D booth, which is exactly on the other side of this curtain, and I'm happy to answer any questions that you have over the weekend. The other question for you guys, I wanted to gauge kind of how experienced we are in 3D printing. Has anyone been printing 1 year or less? Can I get a show of hands? 1 year? Okay, we've got a couple. What about less than 5 years? Once, okay, maybe half of our audience. And then 10 years, between 5 and 10 years. Okay, about another half of the room. That's awesome. So for some of the more experienced ones in the audience, you might notice a lot of common themes that you've heard before, but I also tried to sprinkle in some of my independent research and a lot of data, so hopefully you can still have some good takeaways. I wanted to start with some thank yous right at the top, and I wanted to thank my beautiful wife, Kristen. Here you can see myself and Kristen with our cat, Mia. Mia keeps me on task during the day, and my wife is kind and loving and infinitely supportive, almost to like a weird amount. Like, we were living in a one-bedroom apartment, and I had 3 3D printers just in our living room. I'm really not sure how I got away with that, but everything I'm working on really wouldn't be possible without her. I also wanted to say thank you to a few different movements that have been going on really since 2012. So much of what I'm prepared to talk about today would not be possible without the lowering in cost of 3D printers. So since the core FDM patent expired, the RepRap project, open source ideology, and low-cost microcontrollers have been able to lower the cost from tens or hundreds of thousands of dollars to just a few $100, which is really the backbone of everything that I'm talking about. So much of what I think is possible for the future of plastics manufacturing is due to these movements. So if you've contributed, I wanted to say thank you. And I also wanted to thank all of you. There's so much cool stuff to see in this building today, in this weekend, so I wanted to say thank you up front for spending some of your time with me. My name is Adam Fasnacht. I am a mechanical engineer. I've been 3D printing for over 9 years with printers from under $200 to well over $200,000, from plywood kits to 3D printers that make aerospace components. And I love pizza. And naturally, that doesn't make me particularly unique or special, because who doesn't like pizza? But I've actually been making it from scratch almost every single week for over 5 years now. I've loved it since I was a kid, and it's been a fun thing to get into. I'm also very excited about solving the automation problem within 3D printing and all of the good that that could do, that I'll get into towards the end of the presentation. And 3D printing is a lot of things, to a lot of different people. 3D printing is fun. You can make desk toys and almost any Pokemon figurine you can imagine, which is pretty incredible. 3D printing is also kind of silly. Nope, I am ahead of myself. The first time I saw a Kirby with legs, I was equally amused and confused why that would ever exist. But it brings people joy, and that's a great thing. For some people, 3D printing is purely educational. They learn about it in school, and then they move on to do something with the rest of their lives. For some people, it's a tool that helps them do their job better, whether in an engineering setting or otherwise. And like a lot of us in the room today, 3D printing can be a hobby. It's fun to learn and tinker and modify things and get a lot of joy out of that. But 3D printing is also a revolution, particularly a revolution in the sense of plastics manufacturing. And I imagine many people roll their eyes when they hear the word manufacturing. It's not exactly the most interesting topic. It's often associated with dirty warehouses, but it's also incredibly important. After all, we all have stuff. We all have toys, electronics, thermometers, bicycles, and 3D printing, while it has its drawbacks at times, is actually a really good way to make stuff. And I believe that 3D printing will one day become the dominant method of making plastic parts. And I'm sure it'll affect metals, electronics, and more. But the reason I'm really so convinced about the plastic side of manufacturing is because it's already happening today. But before we get to that, we have to look at how plastic components are more traditionally manufactured. There are a lot of ways to form plastic. You have blow molding for things like plastic bottles, or thermoforming for things like bubble shell packaging. And they all have their place depending on your specific application, but none is really more prevalent and popular than injection molding. I did a little bit of digging, and I found that the very first instance of mold making dates all the way back to ancient Greece in the 4th and 5th century BC. And I'm sure at the time it was absolutely incredible. You know, all of a sudden you didn't have to carve every single piece by hand. If you wanted multiple pieces of the same item, you now had a tool that let you more easily do that. And since then, molds have been used for clays and metals and lots of different cultures over time. But plastics weren't actually molded, injection molded, until 1872 when the very first injection mold was patented. A short 74 years later, some substantial improvements were made, and because this was around the time of World War II, this drastically accelerated the adoption of injection molding because the US was looking for any opportunity to make parts cheaply and quickly. And if you fast forward to today, injection molding is a big deal. It's estimated to be worth over a $270 billion market. It's used for all sorts of products all over the world. If you're not familiar, injection molding works something like this. In its simplest form, you have two halves of a mold. They get clamped together. Plastic is injected. The mold comes apart, and then ejector pins release the part from the mold. This happens over and over and over again to create, like I said, tons of different products. But that doesn't mean that it doesn't have its drawbacks. And one that some of you may not be aware of is that one of the key drawbacks is lead time. When you're trying to make an injection molded part, it's very common to have to wait 4 to 12 weeks to have your injection mold actually made. And then once that happens, you hope that the parts are correct, because if you need to make any changes to that injection mold, you're out more money and a lot more time to have any of those parts made. Injection molding is also inflexible for that reason. So once you wait that time, like I said, more time and money to have any changes made. You really can't iterate cycle by cycle as easily as maybe 3D printing could do. And then maybe the most popular disadvantage of injection molding is cost. I looked up one injection molding company published that on average an injection mold that they would make would cost $12,000. And for all these reasons, unless you're ready to commit to tens or hundreds of thousands of parts, injection molding just doesn't make sense. But when you compare that to 3D printing as it stands today, it actually solves for the main three issues with injection molding. 3D printers aren't expensive anymore. You can get a 3D printer for under $200. You can set it up and have it running in a few hours. Lead time, all of a sudden, isn't as much of an issue. You can choose from any number of brands on Amazon and have it delivered quickly and start making your parts. And they're also infinitely flexible. You can be making Baby Yodas in the morning, whistles in the afternoon, and face shields in the evening if you want to. And that flexibility really applies to making hardware products because, again, you don't have to commit to 100,000 parts and hope that they're right. Instead, by using 3D printing, you can iterate your product more often, similar to how software companies will push out updates on sometimes a weekly or monthly basis. Hardware companies can start to do the same thing. But that's really just the tip of the iceberg. Beyond that, when you buy an injection mold, it really only has value to your company. It's very unlikely that another business would ever want to buy that injection mold and start making the very same part that you are making. But 3D printers, on the other hand, become an asset for your business that have resale value once you're done with them or maybe want to upgrade them. You also have more design freedom, which is probably no secret to many people in the room. But with 3D printing, you can do things that you could never imagine being able to do with injection molding or casting or very similar traditional means. You also have less material waste. All of a sudden, you don't need to carve cavities out of metal and waste all of that material. Instead, you can just make the parts that you need without needing first to make tooling. But I'm not the only one that understands this, and maybe one of my favorite examples is Etsy shops. You can look up right now for 3D printed items on Etsy, and you will find dozens and dozens of people making and selling real 3D printed products. Now, they're not at the hundreds of thousands of units of scale, but it really doesn't have to be a legitimate business and prove, in a sense, that people will buy 3D printed products. One that you may or may not know of is called Voodoo Manufacturing. They operated out of Brooklyn for many years. Fortunately, they're out of business now, but I think there's a lot more that might have gone wrong there outside of the actual core technology. Another one is called Slant 3D out of Boise, Idaho. They operate several very large-scale 3D print farms. And of course, we can't mention print farming without mentioning Prusa, who is one of the more popular names in 3D print farming. And all of these businesses are choosing to use 3D printing to make end-use, sellable parts, all without the limitations of injection molding. And I'm sure you're thinking, all right, if this is all so great and wonderful, why isn't it more widespread? Why aren't more people using it? And the first one of those challenges is education. People who design products are most commonly design or product engineers. And the current workforce, engineers, knows how to design for injection molding. It's what they've been using for years, and it's what they're used to. So on the surface, this seems like a huge challenge. How do we educate over 150,000 engineers in the United States alone, especially when people tend not to like change? But I believe this problem will actually solve itself over time. You see, kids today are learning about 3D printing in their classrooms, in their libraries, and they're not learning about injection molding or urethane casting. The next generation of engineers will understand 3D printing as the default method of making things. And then as they enter the workforce, they will solve problems using 3D printing that the current of engineers never would have imagined. And we know this because of a psychological principle that is known as the law of the hammer, also known as the law of the instrument, that says if the only tool that you have is a hammer, every problem looks like a nail. And this concept is widely attributed to Abraham Maslow, who you might recognize from a high school psychology course as the same guy that came up with Maslow's hierarchy of needs. So he's at least a little qualified to speak on this sort of thing. And ironically, this concept is in large part responsible for why the current generation of engineers doesn't choose 3D printing for their products. Instead, they're choosing a tool that they're familiar with traditional processes as their tool of choice for tackling problems. Our next challenge is consumer fear. And I've met with lots of different injection molding companies and product designers over the years. And when you're designing a product, especially one for consumers, how it looks and feels is important to you. I think that there's a real fear that 3D printed products won't sell. And that's because for so long, injection molding has been the default method of creating plastic products. And there's an expectation that parts are smooth. I would argue that a few slides back, we saw lots of examples of 3D printing farms making and selling real products, and I think that's a good argument that people will buy them. I imagine some people might even pay more for a 3D printed product because they think the process and how it's made is cool. But more than anything, I imagine that the typical consumer never ever thinks about injection molding or urethane casting or sheet metal forming. That's more for nerds like us to think about the processes that go into all of the stuff that we use on a daily basis. And the last challenge that I see is automation. The vast majority of 3D printers, whether they're $200 or $500,000, aren't automated. And it's not a challenge that I see the industry leaders in 3D printing really trying to address. The constant need for human intervention to empty build trays is holding back larger scale adoption. And I think you could argue that if injection molding required a person to sit there and pull every part out of the injection mold, it never would have become the dominant way of making parts that it has. And this is the challenge that I'm most interested in, excited about solving. And I want to share that, but first I want to talk about some numbers as to, just to try to point us in the right direction of, is this actually a problem that needs solving? And over the years, I've heard both a sentiment and a number thrown around that 3D printers cannot ever be used for larger scale production because they are only ever 80% uptime, 80% productive. You have to account for heat up and cool down and manually removing parts, but meanwhile, big business manufacturing, they're always aiming for 100% productivity, so it's not possible. But I wanted to do a good job with this presentation and not just give you a rule of thumb. So I fired up Prusa Slicer and Cura, and I analyzed what would happen if we were going to start a benchy factory, right? Everyone knows a benchy takes about 2 hours on most printers, and I loaded up full build trays, and I charted it out over the course of a full week, and I accounted for, like, maybe you have an intern to come in at 2 in the morning on Saturday, and maybe you don't have an intern, and I averaged out all of those uptime productivity calculations, and what I discovered was it was about 77%, and that's obviously like an ideal situation with someone there as soon as every job finishes. That's not realistic, right? You're gonna have some play in there, so 80% is actually a pretty good number. And for me, it confirmed that if 3D printing is ever going to be used for more than just desk trinkets or prototypes or jigs and fixtures, that this is actually kind of an uphill battle. It would never make financial sense to buy an expensive injection mold and put it in every neighborhood where your product is needed. But if an injection mold were a little bit different, let's say it had the superpower of being able to make any item you could imagine, and maybe make products for multiple companies at the same time as they were needed, it could suddenly make financial sense to put a 3D printer or a plastic production machine in every neighborhood where your product is needed. See, it's no secret that today products are only made in a few places. China makes a whole bunch, the United States makes a whole bunch, and if you add those two numbers together, that's 45% of all products across all categories are really only made in two places. And what happens when you make products in only two places, you get what we call supply chains, which is something that most of us had never given a second thought to until a few years ago. But the world could look a lot different if instead of making products in only two places, we started making products everywhere. Instead of building supply chains, we could make a web. We could make a world wide web of fully automated 3D printers. And that opens up a lot of room for thought of what would the world look like and what problems could we actually solve that aren't being solved today because they can't be made profitably. And I think that the more problems that we can solve, the better the human experience will be. So I'm an idea person. I have more ideas than ever I can possibly pursue myself, and I imagine a lot of other people in the audience are idea people. And when I started thinking about how many ideas never get made, how many problems don't get solved because it's too expensive to be made profitably, because truly that's the reality that we live in. If you can't make a return on investment to solve a problem, the problem just doesn't get solved. If a problem that a physical product could solve is just deemed too small to justify $100,000 of investment, it just doesn't get made. But low-cost 3D printers coupled with automation can let us solve those types of problems that are deemed too small. So what kind of world could we live in if we were able to solve smaller problems? Well, we could live in a world where anyone who wants a prosthetic can actually afford one. We could live in a world where people who have difficulty using their hands for basic tasks that most of us take for granted could have the tools available to do those on their own. And all of these products can be made more locally, which is actually really important and useful. The shipping industry is responsible for 1 billion metric tons of carbon dioxide being released into the atmosphere on a yearly basis. But if we could start making products closer to where they're actually used, we could make a massive step towards addressing climate change. And when times are good, this global network can focus on the good and making things better. And when times aren't quite as good, they can make what we need, where we need, and when we need it, having an even bigger impact. So, one day, I believe at least, 3D printing will be the dominant method of making plastic parts. It'll do that because it actually addresses the three main drawbacks to injection molding that exist in our current world. Excuse me. There are some challenges ahead. However, I think if you look at the first two of those challenges, those will go away naturally over time as the younger generation grows up with 3D printers, a lot like I grew up with computers versus just a generation before me that wasn't something that was possible. And I'm sure some of you are still skeptical. I'm skeptical, so I'm not here to judge. But really, if you look at every revolution in technology, a lot of times they can feel explosive and exciting, but that's not actually the case. They actually follow a very clearly outlined cycle called the Gardner hype cycle. They explode in popularity, dip down, and then build slowly and quietly in the background of our lives until you wake up one day and suddenly that technology is everywhere. You can look at the automobile to ebooks to video streaming to cryptocurrency. All of those technology innovations follow this same cycle. And if you need any evidence of this actually happening in 3D printing, I'd encourage you to look up the stock value history of the industry leaders in 3D printing from 2009 till now, and you'll see a curve that looks shockingly like this. So, for those of you that in the crowd that are less than skeptical, you probably want to engage with this massive paradigm shift in how products are made. And if you make products, you can just choose to 3D print them. It's really that simple. You just have to decide not to injection mold them and start getting all of the benefits available by 3D printing. There's probably going to be a bit of a learning curve. You might have to learn some new design principles. You might have to learn about some new plastics that maybe you aren't used to, but it's entirely possible. And if you are an engineer, I want to encourage you to try to solve problems with 3D printing. At a minimum, when a colleague wants to try to solve problems with 3D printing, allow them to do that. I want to challenge you to think outside of the way you've always done things and try to solve problems. I'm one slide ahead of myself. Okay. I had a credit slide in there to thank everyone where I borrowed information and pictures, but, you know, who needs that? I think I'm uniquely qualified in conveyor belts and automated 3D printing. I've been building them for almost 4 years now in lots of different ways. I'm open to collaborate on projects if you have a product that you want to make, or if you have a 3D printer that you wish was more automated, or if you're an engineer that regularly orders parts and you wish that that happened faster. I have some projects that haven't been announced publicly yet that I think could help with that. Oh, there it is. Anyway, like I said, I invite you to visit the PowerBelt 3D booth. We are right on the opposite side of that corner. Happy to chat, answer questions. If you have business inquiries, best place is my email address. Otherwise, I'm all over the internet at PowerBelts 3D. Thank you.
All right, checking 1, 2, 3. Can you hear me? Everybody can hear me? All right, awesome. Thank you everybody for coming to this. My name is Dan Barousse. I'm one of the founders of Slice Engineering. We make components for 3D printers, FDM 3D printers specifically. We focus on the tool head or print head portion of it. And our whole concept around what we do is we make our stuff here in the United States, and we focus on how do we make the print head really an industrial tool and not just applicable for being sort of a fun hobby thing, but really working on the industrial level as well as in the hobby space. Today I'm going to be talking about intellectual property in 3D printing, which is a little bit of a hot button topic. It's maybe a little spicy or a little zesty in the 3D printing space and 3D printing community. But I'm going to try and address that and maybe dispel some of the confusion that is in the space about intellectual property. So cover a little bit of the history, a little bit of the reasons behind why this stuff exists, and then talk about some potential solutions and how we address it as a company, and hopefully how the industry continues to move in that direction. All right, so first off, what is intellectual property? Usually people think of intellectual property as consisting just of patents, specifically utility patents. Utility patents are a type of intellectual property, but a utility patent covers basically the function of something, how it works. There's also another type of patent called a design patent, and that covers the appearance of something, sort of what in the legalese would be called an industrial design right. But both of them are legal coverings for a particular item, an idea that has been created physically, right? It's a physical object. And there are trademarks. There's two types of trademarks. Trademarks are either a word mark, so just text essentially, or what people most usually think of as a trademark, which is typically like a logo, but it's some artistic design that is protected by the company. And then copyrights. Copyrights are actually the original form of intellectual property. It is the very first type of intellectual property to be recognized as intellectual property. And I'll cover the history of that in a moment, but essentially that covers things like code, computer code, written words in a book or a play, and then art. So that's probably the most common type of intellectual property that we run into as consumers in our everyday lives. But all of them share the common theme that it is an opportunity it's a legal, government enforced, or rather government supported opportunity to have an exclusive right to support your ideas or something that you've created for a particular period of time. So patents and trademarks have they're time bound, they expire after a period of time, whereas copyrights actually continue trademarks continue in perpetuity, copyrights expire after a period of time. All right, so history of IP. Any history buffs here? Anybody like history? We got a few. All right, we've got enough to where I'll cover this in a little bit of depth, but won't go crazy detailed into it. Basically, IP goes all the way back. First concepts of IP came around in like 320 BC, so it's been around for a little while there. Greek philosophers were thinking about ideas and how do we protect these ideas? Where do ideas come from? A lot of philosophers that we would know, Plato, Socrates, they thought that ideas were either inborn, like you came out of your mother's womb and all of a sudden all the ideas that you're ever going to have in your life you already had there, and it just took time for them to percolate. Some folks thought that there was a muse or sort of like a divine, inspiration that came down and gave ideas. And Aristotle was the first guy to sort of dissent from that and say, actually, I think ideas come from human brain and human experiences. Moving on, a couple hundred, well, almost, quite a few years, Tang Dynasty in China, they prohibited the publication of any texts, any works whatsoever that were not specifically approved by the emperor and his team. So first time we see really hardcore government, maybe we call it overreach, that shuts down creative works. Jumping a bunch more in time, 1557, Elizabeth I, Queen of England, creates the first monopolies in history, and they were book guilds actually. So book guilds, they would pay, if you wrote a book at that time and you were an author and you wanted to publish your book, you were required by law to go to a particular set of book guilds, book companies that will allow you to publish. This is where the term publisher comes from, and the whole reason behind why authors use publishers to publish books goes back to 1557. And the author would get a fee essentially for selling the rights to the book once, and then the publishing company collected the profits in perpetuity for as long as the book continued to be published, which was kind of not a great system for the author, really great system for the publisher, obviously, and they became some of the wealthiest people in that era in the 1500s were book publishers. Jumping another 100 years, John Locke. Most of us probably heard of John Locke. His most famous treatise is his second treatise on government, and at that point he's saying he's talking about natural rights, something that here in the States we would consider the Bill of Rights covers the natural rights, things like property. He would talk about the right to yourself, like you shouldn't be owned as a slave, right? Natural rights. And he also talked about the ownership of ideas. So that's where the first sort of modern recognition of natural rights, of ideas being a natural right, comes into play. There's this big court case in the UK, or England at the time, Donaldson versus Beckett in 1774, that basically said property rights don't have, they have certain limits, right? Where your rights might butt up against somebody else's rights, and then you need to limit that for the public good. So that's, we're now going back to this sort of tension between, all right, what is good for the individual person on the natural rights side, and then what is good for the public good? And that would be sort of the utilitarian model of what is good for everybody, but maybe not good for the individual. The biggest probably milestone in all of history in terms of modern enforcement of intellectual property and the way intellectual property works today was actually the U.S. Constitution. So the Bill of Rights, we're all familiar with. That actually, the founding fathers, a lot of them were inventors, and they had come up with ideas they wanted to patent. And so they actually thought that the natural right of having a right to your own ideas, to be able to patent things or copyright things or trademark things, was even more important than the rights that were delineated in the Bill of Rights. So they actually put that in the main body of the Constitution. You can see the text, the actual text there. And then kind of speeding through the rest of this, first international copyright protections, 1891. 1970, the Patent Cooperation Treaty. 18 countries originally signed up for that. Now virtually every modern economy in the world is part of the Patent Cooperation Treaty, and that just allows patents to work similarly and have similar processes across all countries, which is good for individual inventors and for companies that are trying to protect the thing. But the sort of the overarching thing to realize here is that we have an argument of, okay, is when you create an idea, a concept, is it yours? Like, do you own that idea? And that's sort of, and the natural rights folks would say, yes, you own that idea, that is your idea. And then people far on the utilitarian side would say, okay, no, you don't own that idea. Whatever ideas that you come up with, that's a result of your experiences or the people that you've talked to or sort of the public, the community that you live in. And so you don't own any of your own ideas. So we've got these two polar opposite forces that I think, in my opinion, there's a place that we can meet in the middle where you're not saying, okay, everything is only owned by an individual forever in perpetuity and you get these sort of monopolies, versus having everything just be totally open and an individual inventor never has an opportunity to recoup the costs of their investment. Interesting note, one of the most prolific inventors in U.S. history is a woman named Margaret Knight. And just to go back to how ingrained this concept of natural rights is, Margaret Knight was the first female inventor to receive a patent in the United States, and this was way, way, way before things like suffrage were actually granted. So anybody was able in early days, even if you were an indentured servant or in some sort of bondage, you could actually file a patent, file a trademark or a copyright, and get your intellectual property protected before you even had a right to vote or a right to your own property, which is kind of wild to think about, but that's just to show you how deep this debate goes and how intense people recognize, natural rights versus this utilitarian concept. All right, so specifically getting now into additive manufacturing, there are patents that protect most of the original additive manufacturing concepts. So SLA was the first additive manufacturing process or 3D printing process to be invented. That happened in 1986. Chuck Hull invented it and started a company called 3D Systems. FDM, or FFF, was invented in 1988 by a gentleman named Scott Crump. He started a company called Stratasys. Metal 3D printing was, the first metal 3D printing process was called SLM. That was invented by a couple of gentlemen in Germany. They started SLM Solutions. And then so they're all very much on this natural rights side, right? They filed patents, they started companies, they have essentially the legal and exclusive right to use their technology. And then in 2005, Adrian Boyer, he's now Sir Adrian Boyer, he's been knighted, started the RepRap project in the UK. And that was, his whole goal was to open source as much of this as possible. And so this culminated with the modern additive manufacturing industry that kind of got jump-started in 2009, and when some of the key Stratasys patents expired, and FDM companies started to proliferate. A lot of the common names that we recognize in the industry now, Prusa, MakerBot, Ultimaker, Lulzbot, E3D, those companies all had their genesis coming out of some of these patents expiring, which really is an interesting point that we've seen the system working, right? We've got patents that there was a limited exclusive legal right to use that art for a period of time, and then we have an industry that is born out of that without the original, Hull, Crump, and Schwartz inventing those things, coming up with those ideas. None of us would be sitting here. My company would not exist. But also without gentlemen like Adrian Boyer, who is bringing that sort of utilitarian model in and saying, hey, how do we make this more accessible? We don't get the birth of an additive manufacturing industry. And again, none of us are here. So really, again, I'm pointing at this balance of how do you achieve both, right? How do you have the recognition of natural rights and the preservation of something that is important to an individual and also important to the community at large. All right, so why have IP? IP is important for multiple reasons. Number one is protecting the public, the average consumer. You don't want to buy a product, at the grocery store and not know what brand it comes from. You want to associate the product with a particular brand so that you know what you're buying, right? It gives sort of an identity. It's also good for traceability purposes. I was in contact with an FBI agent recently around some stuff, some legal things, and related specifically to IP enforcement. And they were telling us about a story of some folks that they had to track down that were making the little fake 5-hour energy bottles, right? We all recognize 5-hour energy as a brand that we can trust. Well, these guys were taking 5-hour energy bottles that had been recycled, putting their own label on it that was fake but looked like 5-hour energy and was confusing enough that they were selling them at small grocery stores and gas stations, and the product was totally different. In fact, it was what hadn't been cleared with the FDA. Nobody had looked at this product, and it was harmful to people. So that traceability and accountability stuff goes along with the brand and is really important for protecting us as consumers. And then lastly, this is now not looking at sort of the public good in general, but looking at the individual, taking something that could be potentially a secret, right? If you've got an idea, you could use it as a trade. You could use a trade secret, basically something that you just don't divulge. But patenting it actually puts that knowledge out into the public domain. Now all of that knowledge is freely available for anyone to see and read just after a period of time, right? So immediately becomes available, but you're not allowed to use that knowledge to make a commercial product for a period of time. So that helps to incentivize innovation so that you can recoup costs of building a product, building a company, and then also protects inventors and creators, individuals who are coming up with an idea. If you've got an idea that you want to put some intellectual property around and essentially protect yourself as a company, right? If you weren't able to do that, somebody big like Stratasys, for example, could come in and immediately take that idea, and with the bigger marketing budget and the bigger team, they could essentially just wipe you out. So the intent was to protect individual innovators and small companies. So what happens with that? If this happens well, you get this nice virtuous cycle where you invent something, you're able to use those, manufacture it, market that product, and then reinvest the funds from selling that product to inventing more stuff, and that's a great thing. If this doesn't happen, if your IP is not protected, you spend the money inventing, you spend the money manufacturing, you spend the money marketing, and then third parties may come in and clone, rip off, steal, etc. Your intellectual property, your product, and with that it breaks the virtuous cycle. There's no opportunity then to reinvest in continuing to build something that is lasting beyond, maybe a period of a year or two. I've got to give a little attribution here to E3D. Got a couple of E3D folks here in the crowd. They came up with the original graphic that looks kind of like this. Sanjay, who wrote the blog article on this, pointing to E3D's new, as of a year ago, IP stance, used a graphic similar to this, and I think it just really brilliantly shows how this works. This model works well together if you're able to reinvest the profits from selling something back into making more. So who has IP in the 3D printing industry? Literally everybody. Every company that is currently marketing their products on a large scale has IP of some sort, whether that be copyrights, whether that be trademarks. Many have patents. Some of the more famous, wholly open source companies have now started to bring on patents. An example of that would be E3D. And I think the remaining companies that do not have patents yet are being pushed in that direction very strongly by the market, because not having a patent, not being able to basically have a lock on your front door, right, allows just anybody to walk in. There's a reason we have locks on our front doors. There's a reason that we have locks on our cars, because we don't want just anybody walking in and taking what we have, right? We've invested time and money buying the things that are in our house or buying the things that are in your car. It's pretty annoying if somebody comes in and just takes it without permission. All right, so who's taking it? Trolls, number one. So a patent troll, we'll get a little definition here. Patent trolls are folks or companies that come around and they might not have invented a product, or they don't own any IP, or they don't even develop products. They just buy patents for the sake of going and trying to enforce it through legal means or intimidation and extorting money from other players. And that's obviously a frustrating thing for everybody except the troll, but that's why they call them a troll. We don't see a lot of that in our industry yet, but I imagine that will be coming as the industry grows. There's also this whole line of folks called infringers, and this is where I would appeal to you out in the crowd. There are a lot of companies that are cloning or making copycats or counterfeits of companies' legitimate products, and they are then selling them on different marketplaces, especially places like AliExpress. So as a consumer, if you see something that you're like, oh, that looks exactly like E3D's design, or that looks exactly like Slice's design, it probably is. It's probably not a real product. You're not going to get the same level of quality. You're certainly not going to get the same level of customer support, because those funds are not being reinvested back into creating new products. They're just violating other companies' IP. And what we typically find is that if somebody's willing to rip off a patent and infringe on a patent, they're also willing to do that with things like trademarks and copyrights. One of our competitors that is here, been debating all day if I want to mention their name or not, but it's a Chinese company, and when they originally launched their product, they went and took the images right off of our website, copied the text right off of our website. I mean, literally stole, entire web pages, recreated it, and just put in their own pictures of their product in certain places. And that was essentially how they launched their company. So I would ask you as consumers, please don't support that kind of stuff, because otherwise the virtuous cycle breaks, right? There's no way for us to Of course, they're selling it cheaper, right? Of course. But there's no way for us to reinvest and make new innovations, because those companies aren't coming out with new innovations. They are waiting for the companies that are willing to invest in R&D and willing to invest in customer support and trying to build a relationship with their customers to invent something new so that they can then grab it real quick. And then lastly, I'm going to talk a lot of times big companies think, there's the classic example of Ford with the windshield wiper. Maybe y'all have seen this movie, but a gentleman invents the windshield wiper, this brilliant individual, and Ford essentially was like, I don't think this guy can fight us, so they just stole the idea for the windshield wiper and put it on their cars, and this kind of ruined this guy's life, which is really unfortunate. So we obviously want to stop that, and that's where, again, if you know, we all want to support the little guy, hopefully. So if you see in a place where there's an individual inventor who's trying to move their product, you know, support them, even if it's just like retweet, share, like, whatever. That's better, raising awareness about that stuff, to know that this individual person has come up with something cool is gonna, the more that awareness is there, the less likely it is that people in larger companies will infringe. I'll say one note here, none of the companies here in this room are large enough to be considered a big company by the SBA. You have to have 500 employees. But some companies, as they get larger, it's harder not to think, okay, now I'm going to use my muscle. E3D had a recent blog post where they've changed up their IP stance a little bit to say that they're not just going to be on the defensive, but they're going to be a little bit more on the offensive when it comes to patents. And so I'm hopeful that this is not going to go into a sort of a bullying kind of way, but it's going to be continue to push innovation forward in the industry, because that's the last thing that we need. Okay, so FRAND. I think I've talked about answers, right? I want to get to the answers. So FRAND is fair, reasonable, and non-discriminatory licensing. So basically, if you've got a patent, let people use it. If they're willing to have a conversation and there's willing to be an exchange of value there, I think that is part of the answer. So what is the answer? So the way we do this, and the way E3D is doing this, the way a lot of these other companies are doing this, is you invest in R&D, you patent when it's necessary, right, to protect yourself. You open source when it's possible. You allow remix as part of that open source non-commercial licensing. So you're saying, okay, if you're an individual, you bought something, you want to modify it, that's fair game. If you're a researcher, an educator, you want to modify it, awesome, go do your thing, invent something new, right? And then use FRAND, use fair, reasonable, and non-discriminatory licensing to make sure that there is a balance of protection of the individual or a small company versus also the betterment of the public good. So if you want to start a business in this space, I would highly recommend that you get IP of some sort. The current IP landscape is far from perfect. When the original setup in the Constitution was established, you know, it took multiple months to sail across the Atlantic. The world's moving a lot faster now, right? It takes milliseconds to get data from here to the other side of the Atlantic, and it takes, you know, a few hours or a number of hours on an airplane. And the model really hasn't changed, right? It's still 20 years that a patent is valid. So maybe that needs to change. The cost of enforcing and receiving intellectual property has grown and grown and grown, so it's become more and more difficult for an individual inventor to actually go and patent something and protect themselves. And then if you don't enforce your patent, it is difficult to then get any legal protection. So you're basically forced as a small business or as an individual to find people that are infringing and tell them, hey, please stop doing this. Otherwise, you can have your patent invalidated and then you lose that lock on your front door, right? And then I do believe that a hybrid IP strategy that I described in the previous slide is really the best way to balance the public good versus having protection for yourself as an individual inventor or as a small business. All right, got time for Q&A. Gentleman right here.
Mentioned the concept of expiring patents and how that might affect the marketplace, and I'm wondering, are you aware? Can you comment on what might be coming, open in the near future, or in the next 5 years that might, we might see more opening up of certain patents in the marketplace? patents that are expiring.
So probably the most recent example of a patent expiring is the patent for the heated chamber for a thermoplastic extrusion or FDM machine. And we've seen a proliferation now as a result of that. Stratasys had the original patent. Now there's more companies making 3D printers with an actively heated chamber, right? Not just where the bed heater is heating it up, but there are actually active heaters and control inside the chamber, and that enables a whole slew of opportunities to use different, more complex thermoplastics that have more engineering applications or industrial applications. So that's probably the most relevant one that's sort of happening right now. I'm not aware in the next 5 years. I'd have to do a little bit more research on that. The tool that we use most often is called eSpaceNet, and eSpaceNet is a European patent platform, essentially, but it pulls in stuff from the US and China and all sorts of various places in the PCT, Patent Cooperation Treaty network.
Hello, yeah, my question is, the interactions between having a patent and working in an open source kind of environment, where's like the line there? So I think an example I would use is something like, we're in planetary gears, planetary extruders now. What if a company just made a slightly different planetary extruder and then they patent that and then they say nobody else can have planetary extruders? Like do you see like, is there any kind of like tension between open source and patents?
There's definitely tension. I mean, I don't know if you saw my history slide, but the debate goes back hundreds of thousands of years, right? What I'll say is that the intent of the way the U.S. Patent Office and most of the patent offices in the world is set up is that anything that is patented should be a novel invention, right, by definition. So I don't know a lot about planetary gear drive systems, but I think that's a great example. There may be something that's totally new and novel that's possible in planetary gear drives that nobody has thought of before, and it's totally unique, and that may be potentially patentable. But more than likely, there's not a lot of things that you could patent there. And so yeah, I mean, there is definitely a tension. I think that tension is a good thing as long as we balance the tension, right? As long as there is opportunity for the individual inventor of new, novel planetary gear drive thing to recoup their time and investment, right? If they want to start a company, I think they should have the right to do that. But at the same time, the patent should, maybe the term should be shorter, right? There's debate about that ongoing, how, for example, developing a pharmaceutical product sometimes takes 20 years. Having a 20-year patent there makes total sense. But developing a new planetary gear drive might take 1 year. Maybe there should be a 5-year patent, So I'm not an attorney, but that is where I see the direction of things going in the future. All right, if anybody else has any specific questions, we're at booth 39. You can find me there, or just grab me right down here. I'm happy to talk to anybody about this for as long as you're willing to talk about it, because I find it quite fascinating. So hopefully you did as well. Thank you.
I will find a way to put this on a cake in memorial when something happens. So.
Red.
Okay.
We team blue.
Is there feedback if they go too close to each other?
Greetings, everybody. Oh, it's a hot mic. My name is Pooch of RepGord. Not as sexy as Geralt of Rivia, but we're going to go with it. I have a little booth back over here. We make fine filament furniture. But today, what I wanted to do is have a cozy, intimate session here, and we're going to talk about what we are excited about that's up and coming in 3D printing. And this panel is very exciting to me because we've got a lot of thought leaders, a lot of experience in a wide array of backgrounds in additive manufacturing, 3D printing, in both software, hardware. We have influencers, we have engineers, we have materials people, we have chocolatiers. Very diverse array. So I'm very excited. So we're going to talk today in kind of the four major areas that I think all kind of contribute to what's up and coming in the future. Hardware, software, materials, and I would say like a set of components that are like in support of the industry. So like things like automation and tool sets that allow us to do what we do. So your guys' task right now is to be thinking about what is the most exciting part to you, and I'll try to cue you as we go. But I'm going to just toss a little before we get into that, I'm going to give you each 30 seconds-ish to just tell everybody who you are and what you do and what your background is. So with that, John, why don't you start?
Okay. I'm John Schone, and I've got a YouTube channel, Proper Printing, on which I show my inventions, ideas, and experiments about 3D printing. And besides that, I work at an electronics manufacturer, so I'm also in the industry, and I want to talk about what's currently in the industry and how I also translate that to what I show on my channel. And yeah, that's right.
Hi all, I'm Ellie. I'm the founder of CocoaPress. I 3D print chocolate. Let's see, what about me? I've been doing this as a hobby since 2014 and then full-time for the last 3.5 years. And my background's in mechanical engineering. I used to work at 3D printing labs with some high-end industrial printers as well. So I've done a little bit of all the things.
Bollocks. Louder. Yeah.
So I'm Joe, owner of 3D Maker and Breaks and Mix on YouTube. I've been doing it for 6 years now. It has given me quite a lot of insight into pretty much every single 3D printer that there is on the market, or that has been for a very long time. I also do consultancy nowadays on prototyping, design, reverse engineering. I do consultancies with 3D printing manufacturers on how a 3D printer should be, or what the community would like to see 3D printers. And I also teach CAD design at the University of Malta.
And a teacher, awesome. Fantastic. Yeah. Awesome. So as you guys can see, we have a lot of talent up here. And if you haven't checked out Kirimoto, I love this slicer. Browser-based, free. Check it out. Good plug for you right there. So I'm going to start off with just some simple questions, but then we're going to do some Q&A at the end. So if you guys have some questions for the panel, last 15 minutes or so, we'll do that. First question to the panel here, just some soft toss. We've all experienced hardware in what we do, so we're going to start with what is exciting to you guys that's either now in hardware or that you've seen that's up and coming in hardware? And I don't think we have to go in order necessarily, so if any particular person wants to start off, be brave. Yeah. Awesome.
To be honest, for the past couple of years, there wasn't anything, that really jumped out at me. Like, in fact, I kind of slowed down and stopped doing 3D printer reviews because nothing was changing that much. Yeah. Until the
Wow. Sorry, real quick. How many of you guys out here have a Bamboo X1 right now? You loving it? Okay. So familiar with it?
The one thing that excites me about that particular machine is the fact that, as I was telling you, I don't think they scratched the surface of what that machine is capable of. And this is coming from a company who has done that with 3D printing. Close your eyes and imagine 3 years and they know what they're doing. And that's what the interesting.
Wow. We'll get in. We're going to get into that. Yeah.
But yeah, I mean, some things are changing now. Like there's out-of-the-box ribbon machines coming up as well for D3. That's going to be very interesting as well because it's basically something different. And going somewhere that's out of normal is always exciting.
Yeah. Ellie, if you don't mind, if I can jump to you really quick, because you've been doing a lot of hardware development on your own, and I know you've been leveraging what he's talking about in the Voron space, which has seen a lot of development and stuff. Maybe you can speak to some things that excite you in that area?
Sure. Put me on the spot here. That's not what I was going to say.
I did, but no, feel free to pivot to something else if you don't want to.
What's been really cool, so I've been doing this, like I said, since 2014. Over on my booth, I have 4 old versions of the printer as well, including the wood bot that I originally showed off at Maker Fair in New York in 2017, I think. And what's cool is I've been able to build off of all of the innovation that's been happening in the 3D printing space. With the original printer, it didn't have auto bed leveling. It was using 4-point bed leveling. Suddenly I can throw BL Touch on there, an inductive probe, and that's all built right into Marlin. With the newest printer, I'm able to build off of what's happening with the V0. And I think that's a cool way that the 3D printing industry is collaborative in a way that other industries, I don't see it quite as much in. I'm right in the middle between the chocolate industry and the 3D printing industry. And I think that's something that's extremely unique about the 3D printing side, is how collaborative it is and how everyone is building off of each other in a cool way.
very cool. A little louder. Put it in your mouth.
Mm. Interesting. Claire, if I might pick on you a moment. It's not okay. As we're talking about hardware, you at E3D obviously have spent a lot of time thinking about a very specific part of the 3D printer, right? And how a very critical component in the hot end, right? In nozzles and whatnot. And obviously you have new product that you're excited about and stuff, and I'm sure there's plenty of things that you can't even tell us about still. But how does that feel to you to be part of that cutting edge? And I mean, I don't want to pigeonhole you into just being the hot end gal here, so certainly you can talk about other things, but it is and you are very excited about it. I know, just talking to you, you're passionate about it.
Yeah, and I would be purposely staying quiet because obviously a question about hardware and exciting innovations is kind of our thing. But it's really interesting. There's a real theme here, and I'm kind of resonating quite a lot with what other people have said. I think that Joe is right. 3 to 5 years, 3D printing is going to look very, very different. There's going to be what we've all been working on for the last 5, 10 years, which has been developing accessible, reliable, repeatable 3D printing, and that's going to become much more common around the world with more and more repeatable, reliable machines that we're seeing, like the Bamboo, the future of the Prusa printers, the XL tool changer, which is looking absolutely incredible on their AFS system. That's all really, really exciting. But I think we're also going to see the kind of the underground, the RepRap side of it going on. There's that 5-axis stuff that you're seeing everywhere around the show today, particularly if you've got a chance to go to the duet stand, do go and have a look and see what they're up to there. It's quite incredible stuff. So 5-axis and bell printing, and kind of the possibilities that opens up in terms of freedom of build size and shape, but also the on and automation aspect of bell printers. So yeah, there's definitely going to be a couple of branches.
Sure. Yeah. No, you did fantastic. Way better. I didn't give you a very good feed. John, I'm going to try to do better with you. John. Sorry, I'm going to pronounce it right. John. As kind of having more of an industrial background, I mean, I know you have a lot of passion because we all here exist kind of in the hobbyist space. But obviously what happens in industrial can have a tendency to drive innovation in our space, and sometimes vice versa. Maybe you've seen that and you can speak to that a little?
Yeah, but I think it's interesting. I work in an electronics manufacturer, but we are in a project together with Philips. And what I see is we're doing research on 3D printed electronics. And that's something that I haven't seen here, but it's what I see in practice, and especially Philips is doing research on that, on how to incorporate electronics inside of the housing, for instance. And that comes with a couple of interesting challenges, which makes it very, well, for instance, the electronics, normally you think in 2D, you have the print circuit board with the components in two dimensions, top and bottom, and X and Y. But how do you place components if it's on the side, if it's how do you automate that? And how do you place components on 3D printed parts, which are mostly polymers, which cannot resist the temperatures of soldering? And that's very interesting to see, and it also enables some interesting possibilities with incorporating electronics. You skip steps inside of the production process. So you don't have to make a PCB, place it inside of a housing. You have the housing and you place the components on there. So that's what we are researching and how to do that and to see how far can we stretch it and where do we fill and how can we come up with different solutions to make it happen.
I can tell you exactly how to make it happen. I cannot talk a lot about it. As I said, I do consultancies for companies.
Okay.
I currently do consultancy with a company in Mortimer, Schone, which they did invest in a tool changer. For the last year and a half, we've been working together. I've been helping them develop and showing that I'm doing everything.
Wow. Well, that's something to be excited about. You tease.
I've seen the videos of this as well. It's really
Within a few months,
Yeah.
we will be releasing this project and we can realize it. It went through a long process, lots of iterations, but tool changers are fully untapped. The stuff you can do with a tool changer, once you start thinking outside the box, absolutely insane.
Sure.
Look into tool changers.
Yeah.
Okay, so when you're asking about what types of things being said about 3D printing, being said about tool changers, with chocolate, I'm always explaining chocolate to the 3D printing side and 3D printing to the chocolate industry. That's so much fun. But what 3D printing chocolate allows you to do is it allows you to, I'll get back to tool changers, don't worry. What 3D printing chocolate allows you to do is it allows you to customize things without having to make one-off molds. Customization is free, basically.
Sure.
And it allows you to create intricate textures that you can't mold any other way. So it's making the process less expensive and quicker for things you can currently do, and allowing you to do things that you can't do otherwise. A great example of this is just the gyroid infill melts in your mouth in a different way than other things do. What I'm really excited about is once you start getting into tool changers,
Yeah.
suddenly now you can play with flavors in a way and combining different flavors in a single thing in a way that you can't do. There's no other way to be able to combine those textures that overlap, create flavors. Maybe even you could have a tool that injects caramel or something at different points. I think for the chocolate world, tool changers are going to be a game changer at some point.
I mean, if that's not exciting, I don't know what is. I mean, come on.
Slap it on a belt printer.
And you're kind of
chocolate,
you're preempting the whole materials discussion, but I mean that's fantastic right there. Stewart, I wanted to ask you something because we were conversing ahead of this a little bit, and Joe touched on it too. When we talk about things that are untapped,
I'm going to agree with tool changers. Obviously.
Okay?
Right. I didn't mention that at the beginning, but it is huge. I was going to say something sort of a little bit more meta about the software and the hardware side, because you're like, why aren't there 6-axis printers or CNC mills and stuff like that? And so it's an interesting thing where with both hardware and software, integration is relatively easy. Putting together a machine from a bunch of components and integrating them is pretty easy. And the same thing is true on the software side. But when you're building something from scratch, something new hardware, you're designing new hardware, that's a lot harder than integrating hardware. And in the case where we can rapidly build a 5-axis machine, but we don't have the software to drive that, the software to drive that is substantially harder. And so people who are doing software integration and saying, woohoo, I made a software company, like, you're doing integration, you're not actually, in a lot of cases, building real hard software, you're not going to the sciencey side of things. Yeah. That's really where the rub is, and that's what's holding us back, and will continue to hold us back until we really invest in that.
Yeah, so along those lines, you mentioned 4-axis, 5-axis, 6-axis, any of that stuff. We have the hardware for it, but there's nobody developing a slicer beyond just like a pre-programmed, like, hey, here's a demo.
We have hardware that's good enough that the software needs to catch up.
Right.
We could go a lot further with the hardware than we are right now, but there's kind of no point until the software brings us, on parity with the hardware can do.
So my question then, as a follow-up to that is, what about I feel like we keep coming across untapped 3-axis stuff still. Like, how many of you guys have seen like full control, the full control processing stuff, and so just understanding limitations. Like, we're not really using the Z-axis like to its full potential and stuff. Maybe you can speak to that as well. You've written a slicer. You know what that takes.
Slicer does CNC, does laser, does FDM, does all those things.
Yeah.
And so I've been into the figuring out how you make it work. There's a step function both in 3D printing and CNC between. So on CNC, between 2.5 and 3 axis is a step. 3 and 4 is a big step. 4 and 5 is a massive step. And the same thing is actually true in 3D printing. To go from 3 to 4 axis is a step function. 4 to 5 is a massive. And, where there is a lot of untapped stuff, even in, like, I do Kirimoto, which is just me. There are a bunch of slicers out there that have teams of people working on them. And, we just got Arachne, which is a better engine for doing variable width. Just imagine how long it took us to get there, and we're still not tapping the potential.
Question. Sorry, I have ADD brain. It starts.
Go for it.
6 axes on a delta. Can't you just get 2 slicers to talk to each other and do things the opposite way? Because one is moving up. No?
That's a definitive no.
You sure? But have you tried?
I wish it was that easy. Like the multiverse of madness. You're coming at things from an almost infinite number of different possible directions. You can't just make a layer cake. Layer cakes are easy, right? And once you go beyond 3 axis to 4 and 5 axes, there is an explosion in the number of ways you could possibly attack that. None of them are right. Some are just less worse than others.
Less worse than others. Okay.
Dr. Strange would disagree, but I'm okay.
Oh, so Joe says your job is easy, so there you go. What do you think, John?
I was, you're talking about tool changes, and I was doing some experiments with FDM printing resin. So instead of an extruder, using a pump. But one possible solution I see is to mix resins. So if you have a rigid resin and a flexible resin, and if you mix them, you get the properties in between. So what and for color as well, and you can also add a pigment, for instance. So instead of having a tool changer, I'm wondering if it's how you should approach it within the software to to mix the stuff, and maybe also for food if you want to mix ingredients. So instead of just switching,
mixing is like
it's
like the palette or something like that, which basically mixes filaments, which I can't really recommend as an approach because it's very wasteful. But if you have something which flows more easily, like a resin or chocolate, that's actually a much better case for having mixers and augers and stuff like that, where you can actually.
Yeah, that's one thing I'm, especially with rigid and flexible resins, to make robot grippers, for instance, which can grab onto sensitive parts. So you have a soft shell and a rigid, just like your hand.
Like shoes.
Yeah. So you can make organic shapes, and I think that that's also quite interesting to do research on. So
I think that's a good segue into one of the things. I don't think when we think about the future, it's not as commonly talked about, but obviously we're touching on it up here. Materials being such a significant variable in outcomes of what we do. And back in the day, how many of you guys are old school and 3D printed with weed whacker line? You remember that's what it was, and then everybody was doing ABS, right? And then everybody realized ABS is terrible for a lot of different reasons, and now ABS is back again in the Voron world and all that stuff. So we see materials come and go, and we learn stuff, but there's a whole segment of material science, and we don't have. Unfortunately, I wasn't able to find a good material scientist specifically, but thinking about that, and then even thinking about how we loop in other industries by using these motion systems and stuff for completely different applications.
Right. I'm going to just say there are 2 different things. One is about, you wanted to say, why aren't Clipper and Marlin on par? The problem with configurations and dialing those things in, we really need hardware that talks to each other in a more common way. That just doesn't exist. As long as we're hand wiring things together and having to update firmware drivers for different steppers, as long as we're in that world, we're never going to be in a place where the motion systems aren't more complicated than they need to be. And the second thing, if I can remember what I was going to say about that, I'll have to come back to it.
Let me follow up on that. Does that make something like CAN bus exciting to you in terms of creating standards by which maybe we can have a better common language?
It makes the hardware more expensive, but the downstream effect of that is it actually makes control systems and software systems easier to build. And so then there's the calibration part. So you were talking about mixing materials, you're talking about chocolate. You have different profiles which break down when you change anything. You change the filament, you change the temperature, you change the airflow through your room, and it's broken. And so we're going to have to, at some point, have feedback systems built into this, not only components that talk to each other with something like CAN bus, but software that is essentially learning, machine learning, which has a bunch of inputs so it can self-calibrate so that you're not having to build profiles for every single possible thing. Every time you change something, it breaks.
So maybe more closed loop then in things like...
Yeah, it's
okay.
never going to be closed, but closed-er. Yeah.
Okay. Other thoughts on materials and how that impacts what we do?
I think the one material, we have a lot of industries that focuses on, you know, like the technical material, mechanical strength. Like, I'm still waiting for that one company to make a fully biodegradable material.
Yes.
Like proper, put it in a compost bin, biodegradable. Because that will change everything. It will change manufacturing. It will change, you know, how people perceive 3D printing. Rather than being part of the problem, will be part of the solution.
We just need atom scale. We just need matter replicators, so we can just throw carbon in, take carbon out. It's just a lot easier. Or just dump it in the sun.
Just send it to the sun, burn it all up.
There's a 100% PHA, which is fully compostable, which is made by ColorFab. They've been developing it for years. Way back, they launched their PLA PHA mixture. I did. That's standard. I didn't even notice. Didn't even flinch. But yeah, that PHA is actually fully compostable and a really exciting material for the future. It's also incredibly difficult to print at the moment. We're actually helping them optimize that and hope to be able to make PHA more of a thing in the future.
That's good. I've tried PHA, but it's exciting to hear that there is stuff on the horizon. I'm hopeful because obviously we all know there's a lot of waste in what we do, and you know, hopefully there's more.
Materials. Chocolate. So I just need to walk into a room, take chocolate, and walk out.
You've been typecast. You're totally typecast. Yeah.
So in food printing, the three side, how I see food printing is three main segments. One is for personalization, which is what I mostly do. The other two are for environmental reasons and for, I just lost my train of thought. For health reasons, not chocolate. So the health side is, what if you can figure out what types of nutrients that your body needs and be able to print things. Again, it's personalization, but in an ingredients sort of way. I know militaries across the world are working on this type of technology. There's food printing companies working on it. For environmental side, it's how can we have fake meat that tastes like real meat? And specifically, you know, we have the Beyond Beef and Impossible meats.
Yeah.
But those are ground beef. How can we take that one step further and start getting that texture and marbleization that's in a steak? Can you have a signature steak that has a specific texture at a restaurant? So that's some of the environmental side is how can we get fake meat to be as good as real meat? And 3D printing is one of the big solutions there. But on the chocolate side, that's what I mostly deal with. The material science, I like talking about all the other ones. Shocking. And the material science of chocolate is fascinating. It's a shear thinning material. It's real chocolate. You have to temper it. It's a mess. One big thing that we've been working on, I'm jealous of all the companies that have, you know, hot-end companies specifically, filament companies specifically, you know, hardware company, because I'm having to do a little bit of all of them. One of the big changes on our new printer is how can we play with what fats are in the chocolate to have it solidify at room temperatures without the need of a cooling system. And that's where the hardware intersects with the material science, is trying to figure out how can the material science simplify the hardware by a ton. And it's one of the main drivers of, you know, getting the $10,000 cost of our old printer down to closer to $1,500 for the new one. Is we have a new chocolate. It works at room temperatures. It doesn't have to be cooled. I think materials are going to be huge.
So in some ways, you're saying the materials enable the hardware.
Materials 100% enable the hardware.
Again, there are untapped opportunities in the machines that we actually have that are limited by a number of things, whether they're software or materials or other.
And you go to a chocolate shop and you ask for very specific tolerances, and tell chocolate shops you're trying to make a mechanical seal with chocolate, and
they're like, "What are you doing?"
They're like, "What are you doing?"
Yeah.
So it's an interesting world.
Awesome. Here's a question. Did you want to add to materials, or do you want to go on to industrial applications?
I feel a bit guilty because I just blew up 7 kilos of ABS in my garden. So if you talk about biodegradable stuff, then
your garden is not it.
No. Well, one thing is with 3D printed electronics is the materials that are conductive, which is very interesting, but still very challenging.
Yeah.
So what we are trying is that you have conductive PLA, but it's sort of conductive. You can light up LEDs, for instance, but you cannot go high frequencies or high power. But it's conductive enough to electroplate it with copper, and then you get
and then it becomes
full
something.
copper. Yeah. So that's interesting, but that takes an extra step.
Let me ask the audience a question. How many of you guys have played with conductive filament before? And was it frustrating, or were you successful with it? No. Okay. There seems to be a lot of nodding no.
Yeah, and try to solder parts on that. So if it's PLA, how do you solder parts on that with solder which is hotter than 200 degrees without melting?
Did you guys look at machines to do inlays? Like, actually, what's the 3D printer that does carbon fiber inlays? The Markforged. Yeah, so like a Markforged approach where you actually inlay.
That's what we're looking at, and that's also what I'm trying on the research I'm doing on my channel. I've developed an extruder which uses timing belts to push filament, but it's also possible with that to push thin wires and copper wire. And it's basically, it's not new. The industry already does it, but I think it's interesting to get that technology on a cheap printer.
On a consumer level.
So and I also think that development goes faster because, well, it's easier to try and do it at home, and more people will be capable of iterating on that.
Right.
All right, so I've got one more question that I want to ask to the panel, and then I'm going to open it up to you guys if you want to ask as well. I think we hear a lot of conversation about what is it going to take for 3D printing to reach what I'm going to call appliance status, right? Like, when are we going to see it in everybody's home, or will we see it in everybody's home the way that we see a microwave and whatnot? And what are the limitations? And is that even something that we want as an industry? Or is this just what the public at large thinks that they want?
I think what is, you already see it in companies that if you look at 3D printing, a lot of companies think as 3D printing as being an end product. And so, or it's too weak or too expensive for mass production. So, or you get you need an HP jet fusion to get parts that are strong enough to be an actual product. But what I think companies often overlook is to use 3D printing to support the production itself. So even if 3D printing is not your core business, you can use 3D printing to improve your core business. So, and I think that a lot of companies can benefit on having a standard 3D printer and make tools, fixtures, and those kind of stuff. And that can save money very quickly with some very simple tools, which can improve the most simple tasks you often see in a production environment.
So I think there are two things that are barriers to having printers be appliances. The first is materials. The materials that we have today are not suitable for most things around the house, and you can't essentially recycle it. So you're talking about creating a lot more waste, and that factoring out ease of use issues. The thing that I think would make 3D printing an appliance in every home is if you could 3D print clothes and then recycle them on a daily basis. And this is actually something that I was looking at like 10 years ago, which is like the way that clothing is handled in 3D printing. I think it's fun, art house. It's totally wrong. It's not how you would actually, but there is a way that you could 3D print clothes. We can take this offline. It's complicated, but there's a way that you could do it where you could actually 3D print continuous things with no seams and no stitches, with pockets and voids and all those kind of things. And then you basically just throw it in the hopper at the end of the day, have it recycled into whatever you wear the next day. It removes the hole around the world, and the rinse repeat cycle and all that. It removes all that kind of stuff. And I think that would make it an appliance, right? It's not going as far as science fiction-y like matter replicators. This is actually technology I think is within our reach. But I think that's the kind of appliance that would make sense in a home.
That's wild. I'd never even considered that. But your point is well taken that is it going to take an application, a specific application perhaps, for it to grab on? I like that. Did you have something to add?
I think from my point of view, the conventional 3D printing ways we have now with a nozzle and a filament, that will never be a home appliance. Maybe we just haven't arrived to that point where this is noob-proof. And this would work the same way we use a microwave, where it's just, you press 2 buttons and it does what it wants.
Yeah.
Maybe one day we'll find a way to 3D print like an inkjet printer, where it just literally shoots pallets of, plastic, which softens it and just builds on top of that. Rather, see? Just, I call dibs. Okay?
Oh.
Patents. But I don't think that the nozzle extruder filament path we're using now
FDM, you're saying,
ever be
is not.
I don't think it can be. There's still too much hands-on, and I think it can never come to the point where it's fully hands-off, like it cleans itself, and I don't see it. So,
to you, the future is probably something that we maybe haven't even thought of yet in terms of materials and process.
Fully.
So, and you would say the same for something like SLA is not it, sintering is not necessarily it, or is it just FDM you're talking about?
I think, in my mind, it's somewhere along the lines between sintering and FDM, somewhere there.
That's interesting.
Without the messy part, the toxicity part, and the easy part.
Who has more to add? Appliances.
Well, I really hope nozzles take off, to be honest.
Biased much?
I do think that every home in the next 5 to 10 years is going to be using 3D printing in some way or another. I don't necessarily think that everybody's going to have a 3D printer in their home, but we are going to be using them for spare parts, for replacements. You're going to be going to your local print bureau or your, Amazon print bureau, God forbid, but that's probably going to happen, right?
They've been talking about that for a long time. I don't know.
They really have. But yeah, I see that happening in the next 3 to 5 years. So we're all going to be ordering out, I don't know if you have it over here, but the right to repair law. Okay, yeah. I think it's going to be a really, really big deal, particularly for additive manufacturing, and hopefully FDM too.
I was in the line of that. I talked about someone when I went on the plane, and I talked about 3D printing, and she was a manager for several hardware stores, and she was wondering if it would be possible to have how long would it take to have a 3D printer at a hardware store. So you go to the hardware store and need that one specific product, and say, well, just select that one, and it will print that for you at the hardware store. So you don't have the 3D printer at home, but you need it for just that one part. You aren't going to buy a 3D printer for that if you're not into that.
I think that would work with there used to be a machine once that would do multi 3D printing at the same time on the same object with multiple nozzles, like 2 independent extruders would be printing the same item from different angles.
Yeah.
I think something like that would work.
So the big problem of hardware stores is that these specific products that almost no one uses, you need them. You need them ready available, but they can lie there for several years on end, and they are just it costs money to have them. So, and the nice thing about 3D printing is that you have the raw material, so you can just use that and have that in your store.
That's interesting. How many of you guys think that you're more likely to see a public facility like a hardware store is saying, like, you think that? I agree with that. Yeah.
All right,
feels like a bit in between. Having
it's a good
and
compromise to the whole thing, right? And hopefully you'd have much more expensive and capable machines capable of producing much better
so
parts
you don't
than the
have to
average
wait
person.
For 8 hours for your part
Sure.
to finish.
Sure. All right, so why don't we open it up? Are there any questions out there in the audience? And I'm going to have Vanna here take the mic up to you so we can all hear what you're saying. What happened to your hair, Vanna? Just raise your hand and we'll go when we go. Okay, go ahead.
Hey, thanks, guys. First off, thank you for coming. Claire basically answered my 2 questions about the decentralized supply chain as well as right to repair. But let's talk it to the next level of planned obsolescence and working on legislation that, say, car manufacturers only have to manufacture spare parts for X number of years. And then once that's gone, that is lost. And except for preventing things from ending up in our landfills, maybe we need to work societally and within our governments to have, if a manufacturer is no longer making a part, then that part design should be made open source and anyone can manufacture that. And this whole industry has also, for the past year or 2 years, been dealing with the global parts shortage, and that is due to our centralized supply chains. And maybe utilizing 3D printing and the kiosks, or that items can be manufactured and shipped instead of having them all come from one place on the planet and just decentralizing that. I actually had a couple other comments. For the 6-axis printing, think outside the box, think up to the stars. We do it with satellites. We do that on orbit because we deal with XYZ plus velocity on all 3 axes. So think about that. There are tools available that you could potentially utilize to bring into 6-axis printing. The reason I know that?
Oh, we have a NASA engineer among us.
Yeah.
All right.
Yeah. And one other, you guys were talking about not everyone needs a 3D printer. I want to remind everyone of history that nobody will want a computer in their home, and nobody will ever need more than 640K.
I seem to remember hearing that somewhere.
So that's all I had. But again, I would like to hear from the panel of what the thoughts are of potentially utilizing the additive manufacturing technology to decentralize supply chains and try to prevent this from occurring again.
Great question. A lot of meat on that bone. A lot of meat on that bone. Who wants to tackle?
So this is a perfect example of how the last 2.5 years have progressed in Malta. Malta being a very small island, middle of the Mediterranean, like we depend on everything being imported into Malta. And with COVID, with the disruptions, there were it was literally all hands on deck with 3D printing. And that's how the University of Malta continued its projects due to 3D printing. That's how a lot of manufacturers in Malta, restaurant accessories like menus, stuff like that, all 3D printing. So I can see that this has opened a lot of opportunities in Malta. The government has also noticed. Now grants are being offered for companies that invest in 3D printing or include 3D printing in their manufacturing process, because they know that it relies less upon external forces to get the job done.
All right, do we have another question out here? We got a couple people. I want to try to see if we can hit some more questions here.
Hi, guys.
Hey, Jordan.
How's it going? Do you feel that right now we're at a crossing point where...
Little louder, bud.
Do you feel like we're at a crossing point where the hardware is outpacing the software?
Do we feel like we're at a point where
Definitely.
the hardware is outpacing the software?
Definitely. This goes back to something I was saying earlier. It's a lot easier to integrate the hardware off the shelf. We can make 6-axis, 5-axis pretty easily. Even the control systems, how you move something in 5 is not a problem. The problem is, how do you take an arbitrary 3D object and decompose that into a series of moves that's going to build it up into something? There's an infinite number of ways to do that. The layer cake approach that we have for 3D printing bottom up is very easy. Even the belt is relatively easy. You add another axis to that and you're adding infinite degrees of variability. 5-axis is just very difficult because there's no one right way to slice it.
Good answer. Another question out here?
So it's actually a good follow-up to his question, but my question is, I come from the tech world. would like a standardization like group to standardize like the hardware would help a lot on the software, because I know in the computer and
like ISO 9001.
ISO will not fix this problem.
ISO will not fix it. You can say definitively.
No.
Who has other? Will standardization help fix some of these problems that we're talking about?
Yes. I say this,
we have
okay,
disagreement.
Yes,
Asterisk.
I'm all for standardization. That's kind of what our systems are currently about at the moment, making sure that there is consistency across the markets so that the users know what they're going to get.
Okay. So I think the caveat might be that it's not a silver bullet, but
No.
it could be incremental assistance to the process.
Exactly. You got my attention because you mentioned ISO 9001, and that's going to be something I'm bringing up in my talk this afternoon.
Oh, stay tuned for that.
So exciting. Bit of quality management.
All right, we can do a couple more.
Touch that.
You mentioned earlier about the bamboo specifically.
The bamboo,
Now with
yeah.
the bamboo, one of the claims to fame on that is multicolor. But I still see that multicolor as being in its infancy because it maxes out at 32 colors. Is there anything in the future for color mixing and that type of technology?
Many have tried. Few have succeeded, right?
So here's the thing. Prusa created the MMU2, and that opened the possibilities. What Bamboo did was tackle the reliability of it. That is the key point for the multicolor of Bamboo. It's because they have this blade that cuts the filament, so you're never going to have a jam because of wisps. Now, the downside to multi-material is the waste. It's as simple as that. So no matter how much that improves, there's always going to be the tackle of the waste. So I think I think that's the only point of contention with multi-material going forward. I think maybe a couple of years down the line, it'll be like a nonsensical thing because we would have sorted it. But we have reliability from one manufacturer. We have functionality from another manufacturer. It's just a matter of finding that middle ground that would sort it out.
Ellie, did you want to speak to mixing specifically?
Multi-chocolate printing.
Yeah, not with chocolate actually. From my previous job, I think I totally agree with you, and I think that makes sense from the lens of consumer-grade FDM printing. I think it's interesting to note that on the PolyJet side, some of the Stratasys machines, the Connex 500, J750, they're doing some crazy multicolor stuff, clear things, so you can see veins inside of yourself so that doctors can practice and teach. There's a lot of multicolor stuff happening on the industrial level that's really cool. It just hasn't, I want to see it so badly on the consumer side, but it hasn't quite reached that.
Yeah. No, I've seen them at Formnext. They're literally just a skeleton, and you can see muscles and veins and how they showcase how the body works.
It's the same reason you're not going to see laser centering come down to the consumer level. It's a high-end material issue.
Well, and it's hazardous to the.
It's a lot of waste. It's a lot of energy.
The airborne titanium
you can solve the
particles
color
are not good for
problem
people.
with materials, but that's going to be very expensive.
Yeah. So I think to answer your question, probably not in FDM, although it has been tried. I agree. I think the mixing in the PolyJet realm is what's most exciting that I've seen too. And if you go to some of the industrial conferences like the Rapids, the TCTs, Formnext, you see a lot more of that kind of stuff. I wanted to get this guy up top here. He's been very patient.
So will we ever see a day when recycling of 3D printed materials is a reality?
Nick?
See a day when recycling of 3D printed materials is more of a reality.
Right. Will recycling of 3D printing materials be, achievable in any significant way?
That's a really good question.
You can with chocolate.
When you were talking about that earlier, and I was talking about recycling, I'm like, if you start printing meats and you start talking about recycling meats, how far are you going to go with that?
I mean, she basically described the premise of Soylent Green. So that's how far you can go with that.
From my end, I think it's very important to specify what kind of recycling we're talking about here. Is it turning it back into a filament or using it for something else. Or, for example, in my case, those who see my videos know that I absolutely love to keep all the waste that I have, because at some point or another, an idea is going to hit me. I'm going to make something with it.
Do something with it.
And that's my type of recycling. Like, I'm honestly not interested in making more filament. I just want to use the waste that I have creatively.
Joe, that's called hoarding. That's totally a different thing.
No,
but
saving the planet, dude.
Sure.
I don't. Recycling filament is a lossy process. In terms of the quality that you get out of recycling is less than what you put in, and so you can't really do that so far. I think it's much more likely that with filaments you're going to have a cycle that you go from filament to something else, and then it comes back around the horn to filament again. But going filament to filament through recycling is just not a very good process.
Okay. Any other questions out there before we close? Yes, over here. Where's my runner? Look at him go.
Is there anything for the education space that like a teacher can have little experience with and it just works? Like you can just give it to any teacher and they can just have it in their classroom and not have to tweak it and not have to deal with it and not have to take it as like a big part of their job?
That's a fantastic question. That's a great question. I've actually spent some time at some of the educational conferences like ISTE, and I know one of the biggest pain points for teachers is, well, one, reliability, but two, lack of curriculum a lot of the time too. Joe, you mentioned you've taught. Is there anybody else that might want to tackle the teaching question and the simplicity? Or
well, not so much about the teaching, but again, something I'm going to be talking about later is the Sanjay Mortimer Foundation, and that is going to be 100% about providing resources and support and training programs, consistent ones that can be rolled out globally. So for teachers to be able to have access to those, to provide that to those who need it. They're sort of like muttering at each other. I don't know what they're talking about.
2 minutes. Okay, so from my end, when it comes to education, I've only ever used one machine, just one. And it's not because I'm wearing their hoodie, but...
Fanboy.
It's the only company I ever bought every machine I've reviewed from them.
Oh, wow.
So I've probably used in excess of 160, 170 different 3D printers in the past 6 years. Nothing comes close to reliability, from my point of view, of having a machine that I can trust. I can press play and walk away. That's the only thing I have to say about Prusa machines. Like, that's what I use at the university, what I used to do. Like, when you're doing a live example of something, of a print,
yeah.
you want to make sure that it's going to work. And that's the only...
There's a reason we see it is so prolific, and a lot of the booths around here, a lot of the classrooms and stuff like that, it's a proven workhorse. And it's not to say it's the only one, but they've put a lot of thought into that, and obviously they use it as a tool in their own house and stuff. So
granted,
it's a good value.
nowadays we're getting spoiled with speed, with Vorons and the bamboo, but there's always that reliability. There's always that thing at the back of your mind, like, I know that machine is just going to do what I asked.
All right. I want to thank my panel, and I want to thank all you guys for your fantastic questions. This was really, I had a lot of fun. I hope you guys had fun too. If you have more questions, obviously we're all at various booths. Please come find us. We love talking about this stuff and geeking out about it. And I hope you guys enjoy the rest of your show. If anybody is doing our kind of semi-scavenger hunt for our giveaway, the secret hashtag is #FutureIsBright. Hashtag #FutureIsBright. For another entry to our giveaway at RepCord. So, and if you don't know what I'm talking about, go over to the RepCord booth later and you can enter our giveaway. That's it for the plugs. That's it for the panel. Thank you guys. That was a lot of fun. I had a lot of fun and I appreciate you all. Bye.
If you can hear the music, come to the build platform. If you can hear the music, come to the build platform. So this is where I start the karaoke? This is where I start the karaoke. So my presentation was actually supposed to start with a joke around 30 minutes of karaoke. So I thought, you know, if I said, "Sweet Caroline," that's the reaction I was looking for. But instead, we have a special guest here. I was going to show you a violin that we brought, but here we have something bigger. Like Alfred to introduce himself.
Hello, everybody. My name is Alfred Goodrich, founder and CEO of Forte 3D. We have produced the world's first commercially available carbon fiber 3D printed cello. It is a world patented hybrid design utilizing CNC'd regular carbon fiber, along with the overwhelming majority of it is 3D printed using two very large printers, using a Modix 120X and a Modix Big 60 to get going. And this project was started from scratch at the beginning of quarantine when I took my dad's cello to our local children's hospital and got a CAT scan of it, and then took that home and learned how to use Fusion 360. And just started making a whole bunch of cellos that fell apart until finally we found the right recipe to make an instrument that actually sounds good and plays well. And the whole goal of the company is to make these available for underprivileged populations. So a regular cello that you could play a concerto on can cost upwards of 10 to 20 grand, and even a very good student instrument is like 7 or 8 grand, right? For a student instrument, it's ridiculous. And our educational pricing for this instrument is $1,200. So hopefully we're going to be able to get this in the hands of just about anyone in the world who would want it and wants to play the cello seriously and make it a part of their lives. And there's a huge income gap disparity there in specifically wooden classical instruments that we're directly trying to address with the help of some of our partners here. And specifically Protopasta, working on some new designs and execution. So thanks so much for the introduction.
Yeah, great timing. I'm glad you could join. Let's do it.
That's later. That was really special.
That was not what I had planned. That was so special. Thank you very much. Alfred has great timing. He showed up 20 minutes before the presentation here, and we just had to have him on stage to share his work with you. So I really enjoy a good 3D printed instrument. I was going to share about a local violin maker in Portland, Oregon, who's been designing and making violins for a number of years now. You can make your own as well. It's open source. He shares the files. I was going to tease and ask if anyone wanted to come up and play the violin, but I think that was... oh, nobody's following that, yeah. So, let's see here. What's next? Yeah, so I wanted to introduce you to David Perry's modular fiddle, which we have one of them in our space right over there. And you can go to his website, openfabpdx.com, and you can find out more about the violins that he makes. We have a beautiful one over there. The violin that we brought is extra special in that it is made of heat-treated carbon fiber. He does that for all his violins to stabilize them in a hot car or wherever you may take them. The neck on that violin, on that fiddle, also was a special one-off filament that we made together, 20 grams at a time to get the rainbow finish that's on the neck. So be sure to go over to the Protopasta area and check that out. Let's see. Oh, there's a QR code if you want to go to David Perry's site. It's very big. Does it work? Sweet. So that's all my introduction, even though we're halfway through the time I have. I'm Alex, Protopasta co-founder, and like you, I'm many things. These are some of a little bit about me here. I've been 3D printing since 2004, and the first 10 years I was in industrial 3D printing with $1 million machines, and now this is a snapshot of some of my team making filament for the last 8 years. We're passionate about making not only beautiful filament and functional filament, but reliable filament. This here is well, you know, it's not something we sell, so it's kind of hacked together like any good engineering build, but it's to test the feedback, the resistance to extruding filament, so that we can design to make sure that we're reducing the resistance when extruding so that you're less likely to have trouble when printing. So it's kind of cool. Reliability is really important. It's a foundation that we have been able to leverage, not only for giving consumers a good experience when printing for fun, but moreover when supporting businesses and print farms that are printing for their well-being. Out of Darts is an example of that. They recently were challenged by Jimmy Kimmel to come on and do a build that included Protopasta. And I think we should have a video playing here. No, let's say go back. How do I play that? I'm not sure how to play that. So we'll just continue on, but in that video, it's pretty cool. You can get to it from their website and their blog. If you search Protopasta, it's the top. Here, we'll go back again. It's the first hit that you get there. And in that, he talks about his Rivals Jupiter Blaster kit, which we have also an example over in Protopasta in his Proton Purple color that we designed with Luke. It's his company color, it's for him. And also has like a galactic black special black that we made for him that is in between two of the other blacks that we make. And it's been a real pleasure to work with him and support each other, being local, and he has tens of printers which reliably run on Protopasta. There's another giant QR code. Courtney, does it work? So I really like projects like this. I love, with Protopasta, enabling awesomeness. I mean, I want everyone who chooses Protopasta to have a good experience with it. We're passionate about that. We work to make the highest quality filament. We work to support our customers for the best experience. But what gets in the way is when people have trouble, when they're new to printing and something's gone wrong from them and they don't know what, they don't have enough experience to figure it out. We hope they contact us and then we can help them. But we get questions like, what temperature do I print at? I tried all the temperatures. I already tried everything. My filament's full of air. It's tangled. It's wet. The spool is bad. Usually these are not actually what has gone wrong. It's how it's observed or taken in by a new user because they put a filament in and they didn't get the result they expected. So it's actually usually something to do with material handling, some kind of finicky hot end, problematic settings, first layer setup, inaccurate flow, inappropriate print rate, or wrong temperature. Even more so, it's the fact that they don't have maybe the knowledge, understanding, awareness, insight, or experience yet to help get them to a place where they can find out what went wrong. And that's what I hope to address a little bit here today, now that we're 2/3 through my presentation time. I want people to know that Protopasta filament does work. You can 3D print with Protopasta. And I want to give some quick prints for a better 3D printing experience. This is how I would suggest getting started for somebody new. Because the trouble with, for all of you who have 3D printed and done it enough, there's a lot of variables involved, and that makes for a lot of things that can go wrong, even though it can really work out well. So a tool I like to use is printing single walls. And here I have an example with a small QR code. No? Where you can print this little inner diameter guide or protector for the inside of our spool. It's a super fast print. It's like 1/2 gram. And I've posted that up on Printables for you to access. And if you do vase mode, it takes 2-3 minutes. And especially if you do it with a clear material, you get an insight into your process while kicking out so many other variables. You're just looking at extrusion at a single rate and what does it look like. And with clear, you can tell really well, is it fully melted? Is it hazy? Does it have bubbles? Does it delaminate? You get a lot of insight. This is the clear material that we have that I can suggest is like a great starting place. Here it is on the website. And so what I did is I took our Prusa Mini. We did upgrade that with a Bondtech heat break. And that just moves the PTFE junction up higher away from the melt zone, which makes it a bit more reliable. And then we go ahead and set up a print like this in the slicer, and I just wanted to take you through the steps to show you, starting with generic settings and like 0.2 quality. You can have a look at the Aqua box and see where we started, and we're going to step through and look at what settings it took. I selected spiral vase for the checkbox. That sets everything to give me one wall. And then I turned off all my bottom layers. I set bottom to 0 because it will build some bottom layers for you. So that print is going to take a total of 4 minutes if you look at the teal box, and a 1/2 gram of filament. So it is a small price to pay for getting an insight into your process. With that 50-gram coil you saw earlier, you could do 100 prints like this, different settings. I mean, you could really learn a lot about your printer. So here, as I mentioned before, you can see what the extrusion quality and interlayer adhesion is. And you can also check the extrusion width to see what that wall thickness is. So your nozzle might be 0.4, for example, but your extrusion width setting is usually different. You could set it to the same. I recommend setting it a bit bigger than the nozzle opening. In this case, it's set to 0.45. We're actually able to measure this single wall and validate, close the loop, see that that wall is 0.45 millimeters. So it's great. Like we know we have an accurate extrusion, that it's doing what it should. So that helps build confidence in seeing that the printer can do that. Now, one thing I did notice is when doing that print and just changing the couple of settings I showed you, is that the wall was printed at only 15 millimeters a second, yet my perimeters are set at 30. So this is something that like unexpectedly gets folks in that there is settings that tell your printer to slow down, and that changes the rate at which it prints. And this change in rate, either slowing down, speeding up, often can be the root of some problems for you. So what we did is we turned off that slowing down, and we sliced again. We sped up from 4 minutes to 3 minutes. We saved a whole minute, but we also now got the extrusion rate, the speed, up to the 30 millimeters a second that we expect based on the perimeter setting. Here we can use our slice view to also look at volumetric flow, because knowing our volumetric flow or considering that is also helps give us insight into the boundaries of the process. So here we're around 2.7 millimeters cubed per second volume flow with a 0.2 layer, 0.45 width, and 30 millimeters a second. So what's really cool about that print, not only does it give you like a nice smooth inside to the spool, but it lets you explore. You could explore a variety of different widths and thicknesses and speeds, change out the material. You can learn a lot from this quick little part. And if you've got a larger printer or an edge roller and you want to add something similar to the outside of a Protopasta spool, you can scale it up, or you can also find on Printables a larger version of that cylinder, which we use a single wall mode. So I'm using the same settings as before, a printer that's big enough to print that, because that wouldn't fit on the Mini. And I've got an outer ring. So not only does that like improve your knowledge around your process, will this single wall around the outside stick and print and be consistent, but then you also gain this edge guard for if you're an edge guard or an edge roller user, that'll give you smoother unwinding. And yeah, good point. If you have a look over in the rep box, we've got color matched spool edge guards, which is pretty sweet, and like it looks fancy. And here I just wanted to point out a feature that some folks miss. And the corrugation, you've got a nice little spot to slide the filament in to hold it. You're not the only one, though. It comes up again and again. So that's why I put a picture there for all the Courtneys. Here, if you've got a bamboo, you might enjoy that spool guide around the outside, especially as you're changing colors and going back and forth for a better experience. So I love single wall prints. It's sort of an obsession of mine to learn about the 3D printing process. But we can step beyond single walls and learn a bit more. Here's a print I like. It's our logo as a hex P. It makes a great little keychain. We've got some keychains that you can come grab in our space. That's also on Printables for you, and it works really nice as like a bounding exploration to see, do I get the same result in all four corners and center of my print platform? Like before you go and start a big print, it'd be great to have some confidence that you expect the material to stick all across the build platform. So this is 2 grams and 13 minutes, and another opportunity to learn a lot more about your printer. Here's a result on the Mini. I actually did discover during this process that when I put the hex Ps to the back boundary of the software, that I was hitting the nuts on the back of the Mini, so I must be just a little bit shifted. I wanted to go ahead, and I've got 3 minutes here, so I'm going to skate through the rest, which show you our protonome, which I also like as a test piece. And with him, you can do with or without infill. You can do a percentage infill less than 100, or you can challenge yourself and go 100% infill. I added this base as well. He used to have a base. I took it away. He didn't stick to the build platform as well. So I brought a new base back to reflect our new branding with icosahedrons. Here I wanted to show you that another technique I like to use is I like to choose the same speed across all motions so that I know that I have a constant rate, that's not a variable in my result. If you're wildly changing, as I mentioned earlier, the printer slowed down to 15 millimeters a second on that single cylinder, but sometimes you speed up for infill or for supports, and that speeding up and that changing of rate is what tanks the process and gives you a bad experience. Also, sometimes putting material where there's no space with gap fill. If you set gap fill to 0, you turn off that gap fill function. Here you can see some details about the print, and in this case I was able to make the speed constant throughout the print. If I left the other old settings, it would have varied the print speed. And sometimes you can also see that varied print speed on the surface of your part. So if you see differences in sheen, some's matte, some's gloss, that's not the filament. It's probably the fact that your speeds are changing. And I had to mess around and try 100% infill. And in fact, with this good setup where it had the extrusion width that I expect, I was able to do 100% infill. I also turned off any overlap because, again, putting the same material in the same place twice just is a recipe for disaster, in my opinion. So I like to manage my variables when printing and make tests. So I want to give you a stronger foundation in this to make awesome things, because I just want you to enjoy the pasta. And that's it. Thank you.
turn the mic on. Hello, can everybody hear me? Yeah? Brilliant. If I stand over here, can you still hear me? Or do I need to stand right in front of the microphone? Yeah, I need to stand right in front of the mic. Okay, cool. That's good. So, hello everybody. I'm Tony from Duet 3D, and in the next 20 minutes or so, I'm just going to talk about automating all the boring stuff by using what we brought into G-code, which is effectively meta G-code. And it's a bit of an anniversary coming up for Duet. It's sort of a decade ago that Duet and RepRap firmware really started, and I just thought this was quite nice to have a look at. So Adrian's third commit in the lead up to Christmas 2012 is he's not quite sure whether the firmware is finalized yet. That was commit 3. We're now on sort of 3,000, 4,000 commits later, and it's still not completely finalized. Okay, but what, I've been told to get close to the mic. Anyway, one of the things that we did bring in right from the start is this idea that the way the printer behaves should be customizable by the user. It shouldn't be something that's baked into the firmware. And we've had this concept of macros that run for various different reasons, like macro that runs for power failure, or macro that tells you how you want to home your printer, right from the beginning. And so what I'm going to talk about today really just builds on this concept. And here's an example that I pulled off our forum. All of my examples are going to come from the forum. And so if you happen to be Spoon Unit, please shout, because it'd be really cool to meet you. But he said that he wouldn't have even bothered trying to do this sort of print if he couldn't automate as much of the process as possible. It's 136 parts in 2 colors. So what did he do? Well, he basically built a print queue inside conditional G-code, and he built a bed plow that allowed him to automate printing those 136 parts. Now the bed plow, if you've got a belt printer, that's something that's pretty old hat to you, that's fine. But the cool thing is the print queue. So he can just send more files to the printer, and it automatically plows the bed and then prints another set of files. And he built that all in conditional G-code. We didn't have to make any changes to firmware. Now it's not the same as a print farm management software, but he just needed to get a solution, and this allowed him to do it. So what I'm really going to talk about through this talk is like how you can do that, how you can sort of automate things that you want to automate. And it's really from the perspective of I'm expecting you not to be a programmer. So if there are any kind of developers in the audience, this is sort of aimed at people who aren't like programmers and who don't want to mess with the firmware. So first, what is G-code? Well, we use it for settings and configuration, and we use it for machine control. And we, in RepRap firmware, have the concept of using it for macros as well. So homing, for example, or whatever. It means that I can make macros for disco lights, or everybody likes flashing LEDs. So what conditional G-code and meta commands do is they build on this concept further. So the first thing that we get when we start using them is the idea of a conditional. So if something is in a certain state, do something. If it's in a different state, do something else. That's pretty powerful. It's even better when you combine it with loops. So keep doing the same thing over and over again until a particular condition is met, until the state of the machine changes, or you just want your LEDs to fade on instead of turn on straight away. I mean, it's fairly basic examples. And then the third thing that is really powerful is this concept of being able to access the state of the machine. And so by the state of the machine, what I'm talking here is being able to go into the object model and say, what is the heat, this particular heater's temperature right now, or where am I on the, in the motion system, or what acceleration am I using, or basically anything that you can configure or find out from the machine is accessible through the object model. But you can also add your own state in the sense of variables that allow you to store information and then bring them back later. So if we bring these 3 things together, it allows you to automate the boring stuff. And here's just a short video where I'm just sort of going through and showing what our Object Model Explorer looks like. So we're just looking at one of the heaters, we turn the heater on, starts to heat up, and we can go back into the object model and have a look and see what's happening. Not just the temperature, but also things like the average PWM of that heater, what the maximum temperature allowed, what the minimum temperature is allowed. And we can write little commands that access that information. So in this case, I wrote a macro that just echoed that heater temperature over and over again. So just to sort of illustrate what we can do. So now I'm going to give a couple of real-world examples from our forums where people have used this to solve their problems. And the first one is a user on the forum, Chris with 2 S's. He had a pretty common problem. If you've got a big build plate with a lot of thermal mass, your temperature sensor is generally in the heater element. That heats up. It says I'm at temperature, but actually it's not at temperature. So he put a second temperature sensor on the edge of his build plate, and he wanted to wait until that second temperature sensor caught up with the set temperature. He didn't want it to be a fixed thing. He wanted to read what the set temperature is supposed to be and then wait. And Owen D gave him the solution, which just has this 4 or 5 lines of G-code that go in, check the actual temperature sensor, check what it's set to, and once they're within 80%, then it allows the print to continue. Here's another example. User FSK on our forums had a Delta printer with a manual changeable, like either a extruder or a little CNC mill. And he wanted to auto-detect which one was connected and then set the whole printer up differently, completely different config, whether it was going to be a printer or it was going to be a little subtractive tool. And the way he did this is really, really clever, and I really love it. He put a fixed resistor on each of those, a different value, and then he just uses a spare temperature sensor input to read what temperature, what resistor value you've got. So using that, you can then, with sort of 6 lines of G-code, and I've simplified it a little bit just to fit it on the screen, but basically set the whole machine up differently depending on which tool head he's got connected. And I just really love the idea of like hacking the temperature system to give you this extra thing. And I'm just going to work through like a quick worked example here. Pooch is not around. Okay, who's got a filament dry box, or who's built one of RepRap's? They're like really cool, but it's just keeping the filament dry. And so we had somebody on the forum, LBTQSB, said, can we not control that? Can we not monitor that? And can we put a DHT22 sensor in it? Which you can. And it allows the Duet to monitor the temperature of your filament dry box and alert you or stop the print or do whatever you want it to do if it's, if it's too wet. So I should have used blue LEDs for this, not red ones for too wet. So what we want to do, first we have to set up the DHT22. So that's a couple of lines because it's a temperature and a humidity sensor. And we set up the LEDs. Those are just lines we add to our config.g. And once you've done that, you can start tracking the humidity and temperature in config.g. I then split up the requirements into 2 different macros just to keep things really simple. So this first macro just checks the humidity, and if it's over a certain amount, it toggles the LEDs on. Box starts glowing red, and yeah, okay, you've got a problem. The second macro here, this is to tell the user in a prompt in the user interface that it's too humid. So in this case, once again, we're checking that the humidity is over a certain amount. And I've added something else in here. I'm using global variable just to say, do I want to notify the user? Because nobody wants to be notified over and over and over again. It's like, yes, I know. So this allows you to only run the notifications as much as you want. So you might decide, only notify me when the printer turns on, or only notify me at the beginning of every print, or only notify me once an hour if my filament's wet. Whatever you want to do, you can do that. So that's what that second bit is in there for. And this is the notification, like, it's too humid. And then the third part of this, and it allows me to introduce something that we have called daemon.g, which is just a periodic process that runs separate from the other processes going on, like printing processes or anything, that allows you to run something repeatedly. And so in this case, I've just got a little while loop in daemon.g, which calls each one of these macros in turn every 5 seconds. I mean, it doesn't have to be 5 seconds, it's configurable for you. What you don't want to do is like constantly, because then it'll overload the printer, which is trying to print, just checking for humidity all the time. So give it a chance, like, but once every 5 seconds is more than enough. And all of that, we've probably got like 15, 20 lines of G-code of what I've been through, and now we have a filament monitoring system for your filament dry box. If you create a tool, somebody will use it as a hammer, whether you built a tool or not. And Brew Pirate on the forum, is Brew Pirate here? I would love to meet you. He decided that rather than just taking his Marlin configuration.h, taking the values out and putting it in config.g, he would write an entire interpreter for configuration.h, so you drop that in and you get a config.g out the other end. This is not what we designed conditional G code through. That's a scroll bar on the edge, and it's a very, 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 very long script. But it just shows you the sort of power that you can do if you want to. So I've mentioned the forum a lot. If this is something that's interests you, or is something that you want to do more, then please jump on our forums. There's a category specifically around this, and we'd love to help you. There are a lot of helpful people on there that can point you in the right direction on how to use G-code meta commands. Now, just very quickly, wanted to touch on some new stuff, hashtag soon. So we've had the concept of plugins within DWC and Duet software framework for a while. We now have a plugin repository online. You can go to that. So if you are a developer and you want to develop some plugins, we'd love to host them. In RepRap firmware 3.5, something I'm super excited about is multiple concurrent independent motion streams. So you can have the printer doing one thing and have the control system controlling something else at the same time. And I'm really excited to see what people will do with that when we bring that out in the next firmware version. And the final thing, which is sort of a behind the scenes thing, but it's going to be very cool, is the config tool has been rewritten to use the object model. So what that now means is that you can set up a config, we can load it into the config tool, you'll be able to send us your configs to host, so if you've made a config for a particular type, we'll be able to easily host it within the config tool. If you don't like editing the config.g by hand, you can put it back in the config tool, use a GUI to edit it and export it back out again. So that's another cool thing that is coming soon to RepRap firmware. And the final bit of advertising, if you haven't been over to our stand, Ivan has come from Imperial College and brought Open5X with him. And I would really love more people to get involved with multi-axis, non-planar 3D printing. He's made the hardware, or him and Freddie have made the hardware super, super accessible, really low cost conversion for a Mark III or a similar printer. So please do come over and chat to us about that. And with that, I'm open to any questions. If anybody has any questions. No questions. All right, well, thank you very much for listening. And if you do want to chat to me, come over to the stand.
sneak preview.
Just don't want you to step on it. Not horribly close.
Okay.
But speak loud.
All right, maybe just like, well, yeah, that's fine.
I mean,
People will tell me if they can't hear me.
They'll turn you up if they can't hear you. But
Fine.
if you speak too low, they can only turn you up so high.
Yeah, I won't speak low. That's not my problem.
Yeah, I didn't think so, but...
Great.
Good?
I think so, yeah.
Plugged
Okay.
in?
Thank you.
Yep. All right, we are charging.
Now,
Really appreciate the help.
just got to make sure that you speak loudly enough into the mic.
Yeah, we were just talking about it. Do you want it like... Hello? Can you? Oh, good.
We want it low so it stays out of the viewpoint of the camera.
Oh, okay.
But you still need to speak up loud enough so that people in streams can hear you.
Okay.
Got it?
Got it.
We don't care about those two. You know.
What could possibly go wrong?
Absolutely nothing. You got this. What do you need? A little bit of confidence boost?
No, I'm fine. I'm good. I'm not doing it. She's actually going to. All right, I think we'll get started. It's lovely to see lots of familiar faces in the audience. Only 3 years ago today,
Sanjay Mortimer was standing right where I am now, bestowing us all with his wisdom, his knowledge, his energy, and his incredible visionary outlook. Only 12 months ago, Sanjay was with us at the TCT event in Birmingham in the UK, finally able to announce the Revo ecosystem that we'd been longing to talk about and developing for so long. And a few weeks later, we all lost him. Whether working with Sanjay on a day-to-day basis, meeting at events, or simply seeing him on a short YouTube video, although let's be honest, short features weren't really his forte, I think it's fair to say that most of us felt an instant connection, a shared passion, and a not insignificant amount of amazement at the sheer volume of information that he possessed and the exemplary way that he communicated it, taking us all on that journey with him. I do know also for a fact that Sanjay would be absolutely fuming if I spent too much time talking about him over and above the innovation, creativity, and exciting projects going on around us all every day, and how we enable those. So just for Sanjay, I'm going to pivot for a while and talk about some cool stuff. And then just also, because he's not here to reprimand me, we will finish with a short summary of what we've been doing in his name over the last few months, talking a little bit about an introduction to the Sanjay Mortimer Foundation plans and how we hope that you can help. So E3D. Dave, Josh, and Sanjay, the three founders of E3D, had and always have aimed to change the way that humanity manufactures goods. It's our mission statement. Manufacturing itself, if you take that word back to its origins, actually means to fabricate something by hand. That meaning's been lost, or rather changed out of all recognition through the industrial age. Manufacturing is all about how a human interacts with a tool to create something. It's not about just the machine. It's about how we control it in order to create. Since a certain Stratasys patent expired just over 10 years ago, the RepRap project, an open source development of 3D printing, has exploded. It's why we're all here right now, and we have a lot to be grateful for. I can't think of a single individual or company represented here that hasn't benefited from this amazing explosion in creativity and hive mind innovation. It's not new news for sure, but it's certainly context that we at E3D are constantly aware of and grateful for. We're all standing on the shoulders of giants right now. The Wi-Fi was really bad here, so I could only get a cultural references to giants, but I hope you will get it. That hive mind is limited only by our imagination, but as touched on a talk earlier today by our friend Dan at Slice, the actualization of innovation is actually becoming increasingly limited by intellectual property. Not much explanation is needed on this chart, and I promise it is the only bar chart in the talk today. But as I'm talking anyway, I'll give you a short summary of what it shows us and what it can mean. Since some key patents expired over 10 years ago, we all got really excited and creative in the world of 3D printing. This growth in creativity and consequently 3D printing, consequently progress in 3D printing, began to split into a couple of paths: open source and protected IP. Those paths are not always straight, as we know, and not clear-cut. They wind, they intermingle, and their borders can become blurred. True open source designs and creativity always does have its bounds, at least commercially. And as more and more patents get through to granted status, we will and are beginning to see these limitations take effect. I've made up the term free creative space, but I think you will kind of understand what I mean here. Back 10, 15 years ago, there were a few hundred patents being filed in the 3D printing space. As you can see, that's exploded exponentially, and this year we're looking at somewhere between 35,000 and 40,000 patents being filed with some reference to 3D printing. And this covers all types of additive manufacturing too. So as you can see, 15 years ago, there were a few patents, hundreds of patents being filed across all genres of additive manufacturing, not just FDM. So that creative space that we're all working in as a business can become quite challenging. And where does E3D fit into this spectrum? We released V6 in 2014 under a Creative Commons license. It was a deliberate move to enable the industry to grow and great quality printing to be standard rather than by exception. The strategy was successful, to say the least. More than 1 million E3D V6 hot ends are now out there in the wild today. And we've shipped to nearly every country in the world, from Iceland to the Andaman Islands. We even have a reseller in Hawaii, and if you're watching, I'm really, really happy to come and visit you anytime. Clones, of course, became endemic, with varying levels of quality control. And they have improved, to be fair, over the years. But for all of us, not just E3D, this was a success. Soon, hobbyists on Reddit were sharing their ways to improve hot ends and improve extrusion, upgrading to trusted E3D V6, great for us, or one of its many family members. Just a reminder of what those family members are, because I've been with E3D since 2015. The first thing I did in the first 4 weeks was launch this Light 6. We also have the Cyclops and Chimera, Cyclops Aqua, Chimera Aqua, and Plus. We have the Titan and the iterations of that. Bear in mind, all of these are part of the E3D V6 system. The Titan Aero, the Titan Aqua. I actually can't see my screen anymore. We launched the Volcano, a high-flow version of the V6, and again, still compatible. The Super Volcano, which the designer is sat here in front of me, and I think I'm correct in saying that it's 90 millimeters cubed per second output, which is absolutely insane and still faster and a higher flow rate than anything out there in standard FDM. It's also quite a beast. And not forgetting Chimera, which is kind of, I like to call it a gateway drug into the Revo system, because it's the Revo brake that was different between the V6 system and Chimera, and it's the Chimera brake that the Revo ecosystem was also based around. I've totally gone off topic. I don't remember where I am in my talk. Thank you. Okay, as the V6 ecosystem became the industry standard, we were busy innovating behind the scenes. It's fair to say that releasing a product at the scale that E3D is now is far more complex than back in the old days. And I know that we've probably said this in most talks because we always feel like we need to apologize. Back in the old days, we would make a dozen or so prototypes, test them, approve, and a launch can involve only a few hundred units being manufactured. We're not the only ones in the 3D printing world facing this challenge of scale. As a relatively new industry, we're all new at what we're doing. And many of us companies are learning how to scale and scale fast, whilst being affected by a global pandemic, a global supply chain crisis, and something to do with silicon, which I really don't want to think about. I'm really proud to say that this summer, after a lot of hard graft, E3D is being granted ISO 9001 status, the global standard for quality management systems. Thank you to Ken. It's a really, really long way from our informal beginnings, for sure. No more chicken sheds, or at least if we do have a chicken shed, it's going to have some amazing procedures in place. we're all set up for the next stage of our growth and the next steps in E3D's mission. So the future. What does the future look like? I'd love to say it's spaceships and cyborg badgers and all that fun stuff, but in the interest of time, we'll focus on E3D's future plans. So, how to enable everyone to benefit from great innovation whilst protecting the bottom line? Again, it's not just an E3D problem, it's for us all to solve. If any one company closes down their products too much, it can result in branching off of ecosystems, and in the worst cases, actually prohibiting progress. It's something that we're critically aware of at E3D. When we announced our updated IP policy 12 months ago, it did raise a few eyebrows, but in general, I know that we got the most amazing support from everybody and so much understanding, and we're very grateful for that. I'm proud of how we've held true to the promise of being usefully open wherever possible. So, some examples of how we're handling IP in this brave new world. E3D is not an island, although we did start off by living on one. Although we've protected the Revo ecosystem, we are by no means trying to isolate ourselves from the rest of the 3D printing world. In fact, we are proactively seeking collaborations, which many may have previously assumed to be improbable, if not impossible. This is something we've always wanted to do, and now with the Revo system where we can control the quality in the supply chain, we have this chance to do so. Our recent Revo collaboration with BQ, with their H2 Revo, was quite a surprise to many, and I hope a pleasant one. And today we're also announcing a collaboration with MicroSwiss. Again, a company that most would have seen it as a direct competitor of ours, but integration and collaboration and spreading a consistent ecosystem, reliable ecosystem across the 3D printing hemisphere is really important to us. If you're at the event, please check out the MicroSwiss NG extruder with the Revo hot side. It's on their stand, and I think that we've also got one on the E3D booth right now. Yeah, we have. LDO are now producing their own Revo Voron heat sinks in line with our open cold side policy for Revo. And their Voron kits will be shipping with Revo systems really soon. There's some more exciting collaborations which I can't talk about, but all have the goal to enable more and better printing. This policy of open collaboration with great partners around the market means that although we've protected our bottom line with proactive IP filing, we're also doing our very best to enable industry-wide adoption of new, user-friendly, accessible ways to interact with our printers, and ultimately enabling incremental changes in how humanity manufactures goods. How we interact with our tools in order to create that original definition of manufacturing. It's really quite exciting, and we're grateful for the partners and collaborators joining us on this journey. Now that I've mentioned collaborators, it seems like a good time to me to introduce the Sanjay Mortimer Foundation mission, because collaborators and collaboration are going to be the key to its success. Slides. Okay, they've caught up with me. The Sanjay Mortimer Foundation, or the SMF, is a global non-profit initiative to find and assist those with neurodivergent minds to realize their potential through engineering and making. Its purpose is to discover and unlock the potential of tomorrow's brilliant engineers. Why are we doing it? To continue Sanjay's legacy. He was a passionate, neurodivergent thinker, diagnosed with ADHD only relatively recently. His passion in life, other than hot ends, was education. He recognized a clear gap in the modern education system where engineering doesn't just play second fiddle to mainstream subjects, it's often all but ignored. He had a long-held belief, which was a driving force in his life, that engineering should become a core part of the curriculum once again. He's not here to share this message, and so we're going to do it on his behalf. How are we going to do it? Firstly, we will share that mission globally. We'll build partners and collaborators to help us spread and then realize our mission. And that will provide access to SMF support in the form of cash, resources, training, mentoring, and even placements within partners within the 3D printing industry and the wider engineering market. This is the bit of the talk that actually got corrupt and got deleted about an hour ago, so I'm just going to ad lib now. But this is a call to arms. We are really, really keen on finding collaborators that would like to support maybe those who already have experience of neurodivergent minds, and the different paths through education that those people may take. We already have two fantastic collaborators, partners, one of which is the Museum of Science and Industry in Chicago. They have the 7th ever Fab Lab there. It's run by a wonderful guy called Dan Meyer and the Wanger family. My team's laughing, I can't imagine why. But they're going to be helping us develop a global network of education systems that are reliable, repeatable. They've already got it, and they have already been trying and testing it with great success within the Museum of Science and Industry, and they're very kindly going to lend us that MakeX system for part of the Sanjay Mortimer Foundation. We're also, at the moment, onboarding with Google as a Google charity. So Google employees, if they want to support us, which is something that Google really tends to encourage them to do, Google will be match funding all of the funds that we raise in the future. Just give me a moment because my talk just deleted itself. It's going well. So through the network that we plan to build, we aim to support those neurodiverse and talented individuals in a systemized and practical way. If you'd like to join us, please do. We're currently setting up a website and our own email addresses. We have the trustees now in place, and the charitable organization is in progress. We've raised over £80,000 so far to date with the help of a large amount of people right here, right now, actually, and I want to thank you all. If you want to get involved in any way as a trustee, perhaps in the future, a partner, a collaborator, fundraiser, whatever you would like to do, please email us at smf@e3d-online.com. So, you'll have noticed I haven't talked about plasma flow resonance once in this talk. That's because I'm not Sanjay, and I'm not even going to try to pretend to be. We do have some unicorn-level obsidians on the stand for anyone that's here today. 12 months after Sanjay proudly announced them to the world. I'm so happy he got the opportunity to do that, even if we then did have to deal with the 12-month delay afterwards. If you're here, please come along, and we'll be delighted to show you what the fuss is all about. It's certainly been a wild ride developing what I suspect is the most long-awaited nozzle in history. Whilst I'm not Sanjay, I know that he would like to have the final word. He was a man of many words, and he had many favorite sayings. I'd like to share two of them with you now. The first was this: they say you die twice. Once, when the final breath passes your lips, and again when your name is said for the last time. With your help and through the foundation, we hope to make sure Sanjay lives on for many years to come. The second saying, and the final words for this afternoon, was this: I bloody love hot ends. I don't think I'm going to do Q&A because I might cry, but do come and talk to me on the side, and I'm very, very happy to chat anything through if you want to have a bit of a chat about the foundation, but I'm not going to do it up here. Thanks very much.
Hey everyone. Can everybody hear me? All right. I'm Joe. I'm the founder of Project R3D. Everybody knows this is Project Red. So today we're going to talk about a new hybrid motion system combining combining tool chaining and IDEX onto a Core XY system. So let's get into it, right? So let's talk about IDEX first. IDEX is great for a lot of things. Here, the main advantages are tool printing without the fear of digging your second nozzle into your print while you're printing with the other hot end. You are able to park it off to the side. And both tools being mounted to the same gantry makes it to where you can't really drop tools, which we'll go over a little bit later. Big disadvantages are, like on the BC and Sigmas, you have to shim the second head when you want to print at the same time with both of them. Otherwise, the second nozzle is a little bit up so it doesn't drag. The weight of the second motion system for the second head is all on normally your X. The risk grows with the bed size. So we've been working with a lot of printers that are in the 700 millimeter to 500 by 500 millimeter bed range. And with IDEX, the benefits of mirroring you can use the benefits of mirroring, but once you get into duplication, when you're trying to do like 50 parts at once, one part failing to kill the other 49 really becomes a major risk when you're trying to get production parts out there. So in print farm situations, your risk to reward is skewed way off, and it just becomes not worth it. Normally, you just use a second head as your support material or just a different color. Oh, let's go back one real quick. Limited to 2 heads. Really, there's not really many IDEX printers out there right now. They are becoming more common, but you're really limited just to 2 heads on the sides, mainly because of the weight of the second motion system, adding a third or a fourth. There are some people playing with adding a second gantry, but at the same time, you are adding a significant amount of weight. And limited to standard bed probing. You're gonna have to end up using a probe, like an inductive, capacitive probe. There's the clicky mods out there for the Vorons, which are awesome, but you don't really see them on things like BC and Sigma and stuff like that are your main IDEX units out in the wild. Now the tool changer from E3D, awesome system. It's a development platform. I use them quite a bit. They're awesome machines. Big advantages, your 4 tools / materials. You can use 4 different materials. It's been great for testing. Tools of different lengths, because you go and park your main tool or the tool you started with and pick up the next tool. You can have them at any length you want, as long as your bed can move in that distance. And full probing with mechanical probes. That's one big thing I loved about the tool changer, was that it had a clicky probe mounted to the bottom of the X gantry. So when you park off your tool, you can probe the full system, and you don't have the hysteresis that you see with inductives and capacitive probes just from the heat. And most hysteresis are 5 to 15% on even some of the best probes you can get. Big disadvantages, we had 4 tools, that's awesome, but you can get a drop all 4 tools. If anybody's dealt with a tool changer and you put on a brand new hot end and you drop it and you throw $300 out the window, and you gotta fix your hot end. So that's one big disadvantage. If you just have one misalignment, your day is bad. Technical experience needed. The E3D tool changer was a development platform. Does a lot of great things for development, but you do need a decent amount of knowledge before digging in. So we decided there had to be something different, but we needed to decide what we wanted to do. So what we wanted the advantages of the speed of Core XY. We wanted multi-material, like a tool changer. No chance of dropping tools like an IDEX. Lightweight to an extent. We're gonna show you something that we went a little overboard with. And rigid mechanical bed probing. So we're gonna work through this together. If you guys have any ideas, let me know. But we'll see how I solve this issue. So dropping tools. You think about dropping tools, how do you solve that? Oh, it's easy. Do it what IDEX did. Put it all in the same gantry, make it to where it's rigid mounted. You can't drop it. All right, let's do that. Like I said, we went a little overboard. Those are two 2-inch square steel tubes, 1/4-inch thick, welded to a 3/8 steel plate. That is a 25mm ball screw. Mounted all of them on two 20mm linear rails from THK. I went a little overboard. All right. Now we got to figure out tool changes. Well, someone did it well, someone did it right, but they let us drop our tools, which made me sad. So let's do it a similar way, but let's make it a little bit different. So we've got a center head that has all of your motion. You also have your lockup system. So on this specific one, we use 50-pound springs. We have the T-bar from the E3D tool changer. We have a 3-to-1 gear ratio with a NEMA 17. You see how big this whole system is? That little tiny motor at the top is a NEMA 17. I went a little overboard. And that little thing at the bottom is a giant end stop. Overboard. All right, so when you bring over your second head, it locks in similar to an E3D tool changer. We want stainless steel on the bar, the post, and the lockup cam, mainly so we can harden the cam. So if we ever do have to replace something, we replace the T-bar. Easiest thing to change, quickest thing to change. So what did we gain? We gained one driven system, up to 3 tools, rigid mounting of a mechanical probe. So what you do is you remove the center head, take the hot end off, and put any mechanical probe that you want that's actually rigid. You don't have to use a servo to raise and lower it. Biggest problem with when you put a very nice rigid mount probe, you tend to have to put it on a servo or some kind of motion to drop it down, or else it hits your print. Well, if you have your heads on both sides, so your tools 1 and 2 positions, and your tool 0 position, you can just have the probe mounted, and it can lower down to the bed completely, even past dropping the heads off the sides of the bed. So the overall cost was a big advantage as well. So we don't have 3 motion systems. I showed you that we went overboard. That motion system is about 300 pounds. So when I said lightweight, it's relative, all right? So moving to, if we had to do 3 of those motion systems for the 3 heads, you're looking at 3 NEMA 34s. You're looking at 3 20mm or 25mm ball screws. We'd be significantly over 300 pounds. So one big thing is we have the speed advantages of a single head, because that's all that's driven. You pick up on your main head, you just run that. If you don't need your support at that point in time, you can run at full speed. Once you go pick up the other 2 heads, you drop the speed slowly. If you guys listen to the duet talk earlier about conditional G-code, we use conditionals to slow it down when you pick up your second head. Yeah, so I showed you a bunch of renders. Those are cool and all, but nobody likes renders. They're boring. So let's talk about the printer. About a year ago, I went out to IC3D. They hired me on as a consultant to work for a little while, building a smaller printer with them, because they had all these cool printers, but they didn't have the experience building a large amount of units. And then my time was about up. I did a 3-month contract with them. Time was about up, and they came to me with this crazy idea, and they always knew come to Joe for the crazy ideas, because he'll make them crazier. And they said, hey, we have this printer that we need to build for a client, 1200mm by 1200mm, but they want 3 heads. And they said, oh, well, we're going to do IDEX. We're going to do IDEX, and we're just going to strap a second hot end to one of those IDEXs. And I was like, yeah, I got a better solution. So Project Red, about 6 months earlier, I had started working on this design of this hybrid motion system. I said, well, let's do this, and I sold it to them. They immediately sold it to their client, and they were gung-ho. So this printer is about 8,000 pounds. The bed has 9 individually addressable heaters. It's a 3x3 grid. The frame is a 3-inch square, 1/4-inch thick tube. It's got its own PC. It's got a huge electrical cabinet. It's run off the Duet 3. It's got a total of 12 boards on the can. So it's giant. We went a little overkill. That's kind of what we do. So here's the lockup in real life. Ignore all of our temporary printed parts. and stuff for that wiring. But so we have our NEMA 17 with the T-bar lockup and the single-driven ball screw. So only this main head is picked up. The other two heads at this point in time are parked on the either end. That's tool 1 and 2, held to the ends by magnets. There's where we cam into. We just go pick it up on either side. These are off the edges of the bed far enough that when you have tool head 1 locked up, you can move tool head 0 all the way off the bed, so tool head 1 can touch the whole bed. You're not losing any space, but the printer is kind of large. The printer is 8 foot by 8 foot by roughly 8 foot tall. All right. This is the team that worked on it with me. So we have me on the, the guy that looks like me is me, if that works out for you. The main engineer that worked on it with me is Anthony. He's the one sitting. We had another engineer, his name's Greg. The guy standing, and in the back is my electrical. His name's Philip, awesome kid. But yeah, that kind of gives you a relative size of our machine. We could all have meetings inside. And that back cabinet has all of our CAN boards in it and everything like that. So it's relatively large. So we did the thing with IC3D. We delivered the first printer on Monday. So of course, when I have IRF to worry about, I also have to deliver a printer. So up until the last day before I came here, I was tuning that printer at a client's facility. So, but how does that work into Project Red? I don't know if any of you have seen our booth in the back. We have the Daedalus series printers. So we started that back in January of 2020. We released them we started production in September of 2020. We released it at the IRF that was all online in 2020. We started shipping at the end of October. Project Cerberus begun. And that is our 3-headed system. That is our Daedalus Pro. So that is what Cerberus became, what IC3D now calls the Triflex system. And that's what's on the IC3D 1200 printer. Right now, we just unveiled the Daedalus Rev 1.5. The Apollo began shipping right after MRF of this year. And Q1 of next year, we're going to be doing Daedalus, well, in the next 12 months. Daedalus comes out at the end of this month. Apollo add-ons, which is our other small printer. And then the Daedalus Pro is releasing Q1 of 2023. We're shooting for a 400 by 400 by 400 millimeter build volume. It'll be a 3-headed system. For most people, you won't need the 3rd head. The center head will be a probe. So you can do active probing with a mechanical probe. You're not going to have your hysteresis sways of up to 15%. And it'll allow you to do all your different materials with 2 different heads. So that's kind of what we're working with. So I just wanted to give you guys an update on that. And if you guys have any questions, feel free to stop at our booth at the back of the building. And thanks for coming. I appreciate it.
I'll go ahead and get started. Sorry. I talk loud. I'm a university professor at the University of Maryland, so I'm used to projecting to a room in a lecture, but I'll try to make this a little more entertaining than my standard biochemistry lecture for you. But before I start, I want to thank the organizers. So Nick, Lauren, Chris, Vicky, and everybody else who's helping out with this event. Thank you very much for all the hard work that you've put into this. And I'm really happy to get to see everybody in person and a lot of people who I haven't actually met in person before, but know from the community. So today I'm going to tell you about OctoPrint, and the way that I'm going to go through this is that I'm going to tell you very briefly about what OctoPrint is. I think most people have an idea. I'll tell you why you want to use it. I'll introduce the idea of using multi-instance OctoPrint and why that could be beneficial for your 3D printer setup. And then I'm going to try something that is usually a little bit dangerous, but I'm going to do a live demo for how to do this for you and show you that this can actually be, I hope to show you, that this can actually be a very easy process. All right, so what is OctoPrint? In very big brush strokes, OctoPrint is a host control system. So the idea here is that the G-code that your printer is going to be using to run particular commands is sent from a host device. This is some kind of computer to the printer via a serial interface of some kind. Typically, this is going to be a USB type interface. OctoPrint was created by Gina Hauska, and she's the primary maintainer and creator of this, and this is an open source project. And Gina puts all of her heart and soul into this, and this is her full-time job. So if you use OctoPrint, or if you're thinking about using OctoPrint, it's important that you donate and give something back to the people who are putting all the effort into making these open source projects. You can donate to OctoPrint here, and I'd add that we're in a unique position in this community where we use a lot of open source software. So we have the opportunity to be able to give back to those people. So Scott from Marlin and all the other people who are generating that open source software, if you're using it, it's always a great idea to give back. And you know what? It feels good too. All right, so why would you want to use OctoPrint if you're not already? First, I would say that the idea of not having to use an SD card anymore is very appealing. No more sticking it in and out of the computer after you slice and taking it over to the printer. You eliminate that entirely. And I think one of the coolest things, and Gina has said that it's her favorite part of OctoPrint, is this powerful third-party plugin system. And the idea here is that we as a community can find features that we want to integrate into OctoPrint, write those ourselves, and make that part of the OctoPrint community, and use those for doing all kinds of different things. And while there's, the Duet web interfaces, web control, and all those other things, OctoPrint certainly has the largest amount of these third-party plugins that do all kinds of different things. This has a web interface, so you're uploading through, another computer. You can have an embedded camera. Stream within OctoPrint allows you to do rapid monitoring and see what's going on with your printer while you're using it. And the thing that I use OctoPrint for the most is just direct slicer upload. So your typical slicers you're using, Cura, Prusa slicer, you have the ability to use application keys or API keys and send that G-code directly to your printer and start printing immediately, right after you've sliced. So those are some reasons why you'd want to do it. So now I want to look at how this is typically set up. So what does a normal OctoPrint installation look like? So the most common hardware that's used for OctoPrint is a Raspberry Pi. That was how it was originally intended and how it was developed. But because it's developed in Python, it's really system agnostic. You can run this on any Linux system at all. It'll run on Windows, it'll run on Mac OS. So there's a lot of potential options there. In the Raspberry Pi system, this is typically done with OctoPi. This is a Raspberry Pi OS image that is pre-installed essentially with OctoPrint, with a web streamer that allows you to flash that directly onto the SD card that you're going to use with your Raspberry Pi, and you have OctoPrint up and running immediately after you have that set up. Now, the thing with that is that the way that system is designed is for a single instance of OctoPrint to be running. So you have one printer for each Raspberry Pi that you have. And I don't know if anybody's tried to buy a Raspberry Pi recently, but that is quite difficult to do. And if you find them, if you go to eBay, you'll be wondering why you're paying as much for a Raspberry Pi, or close to as much for a Raspberry Pi as you would be for a printer. So there are solutions to this, and one of those is to change how we do this and instead use multiple instances of OctoPrint on any single computer. So this is the idea that we have one host, one computer, but you're able to control many printers from that. Now, there are many available guides if you start searching around on how to do this. There's a guy named Chris Riley, who's right over there, who has a very popular YouTube video on how to set this up using Octopi as the base instance. But I think Chris would even agree that the system that he's developed and all of the other guides that are out there, it's complicated. And if you're not someone who is used to using Linux or editing system files, this can get very complicated very quickly, and as soon as one thing breaks down, the whole system is broken down, essentially. There is also hardware variability. So the printers that you have and the printers that I have different characteristics, and how you're going to use those when you're following one of these guides can change depending on what the printer is. So my solution to this was to come up with a way that you could make this essentially hardware agnostic. There doesn't care what the printer is, and the only concern that you have is that the system is running some kind of Linux. So I've made what's a guided bash script, which I call OctoPrint deploy. And this is essentially going to do all of the features for you. So the first thing that I'm going to do is I'm just going to walk you through the idea behind how this works, and then we'll do that live demo. So the only thing that you need to have for OctoPrint deploy to work is that this has to be some kind of Linux system on some kind of computer system. This can be a single board computer like your Raspberry Pi, Banana Pi, Orange Pi, all of those different things. It can be an old laptop from 2020, like what I'm using to give this presentation right now, and we'll do the demo, and you have sitting around. But all it has to do is have some kind of Linux flavor on it. And you can download and install that quite easily. The first step in this process is making sure that you have OctoPrint installed on that system. So the first command that will be as part of this guided script is to prepare the system. This is going to install OctoPrint. It's going to install some kind of webcam streamer, and you can install things like HA proxy or HA proxy, which is a backend system that makes things a little bit easier as a reverse proxy system. So you run through those commands, and the other things that this script will allow you to do is it'll allow you to do things like set up your admin user and run through all of the first step things. If anybody's ever set up OctoPrint before, there's this first step wizard that you run through as soon as you connect to it. This will allow you to do that all within the script. So you never have to connect to an instance to set that up. What this will create for you is essentially a template instance. This is the thing that will now be cloned when you're going to make all the rest of the instances that you're going to connect your printers up to. So the admin user is going to be the same between all these instances. If there's a plugin that you like, that you have certain configuration files for, you can add that to this template instance, and then that will be propagated to all the additional instances that you have. So the next step in the process of this script is to select a new instance. And it'll guide you through this process. You give it a name, and by default, this is going to be a printer that's an OctoPrint instance that's going to be running on port 5001, where you're going to hook your printer up to. Now, one of the complicated things about doing a system like this is how does the system that you're running know that this OctoPrint instance is related to this particular printer? Right? Because you're going to be connecting multiple printers up to this, you have to have some way to know which printer is which. And you want that to be propagated all the time. Every time you reboot the system, you want that to be the same. So the thing that I'm most proud about this script is that at this time of establishing a new instance, one of the things you do is it asks you to plug the printer in via the USB cable. And by doing this, what this does is establish what's called a UDEV rule. So the UDEV rule will, if your printer has a serial number, it will detect the serial number of that printer, and it will now automatically always associate the serial number of that printer with that particular OctoPrint instance. If your printer does not have a serial number, and there's a large manufacturer in China that makes a lot of printers that a lot of people have that never have serial numbers, and it's rather annoying, is that it will actually detect the physical address of your USB port. So as long as your printer stays plugged into that particular USB port, it will always be detected at that same place. Now, one of the other things that we can do with this is use this same idea, but now for your webcams that you want to set up to use with your OctoPrint instances, you do the same thing. So either at the time where you're setting up this instance, or you can even do this at a later date. You can add cameras to these. It'll do this UDEV rule detection for your USB cameras. It does not work with PI cams, only USB cams. But now you can set this up so that that camera will always be associated with that OctoPrint instance. And now you get to go wild and you get to install effectively as many instances as you want running through this same thing. So the advantages of using the system more than anything else is that there is no text editing. You enter the name of your printer and maybe a little bit more information, but you do not have to edit any files anywhere. This is all handled in the system for you. This in turn makes this very fast. So in doing this, the slowest part is actually walking over to the computer and plugging in the USB port for doing the detection. And one of the other things is because I was sort of figuring out how to do all these things, there are a lot of little things that are part of the guides that people give you that can easily be overlooked. And this script handles all those things, including making sure that the users have the proper permissions in the dial-out group, in the video group, and there's even little packages like in Ubuntu that now conflict with USB devices. So this script automatically removes all those for you and has you running smoothly right away. All right. Some features that I'll talk about and then get into the demo is that if you know about how these systems work, all the instances are running from the same virtual environment. So that means they're sharing the same binary file. So one of the things you can do is if you're running 10 printers off of one laptop, if you update one of those instances for an OctoPrint update, or you install a plugin on one of those instances, when you restart your other instances, all those other instances that you restart now will be updated and will have that plugin in there. The important thing with this is that the configuration files for those plugins are all independent. So you might want to have those printers set up with different plugins with different configurations. They'll have the same plugins, but you can configure them differently. There's no contamination, if you will, between the instances in that sense. And in the same way, one of the things the script does is it automatically changes the title of the instance. It automatically changes the restart commands. So all of those things are associated with a particular instance of OctoPrint. It also updates the UUIDs. So if you do things like integrate OctoPrint with Home Assistant, for example, it needs to have a unique identifier in order to be part of Home Assistant, and the script handles all of that for you at the time of setup. So it makes it much, much easier to use. All right, so here we're going to go into the demo. So I'm using a Dell 6230, this tiny little thing. It's an i5, probably from 2011 or 2012, with 8 gigs of RAM. I've got Ubuntu 22 installed on it. Totally bare. I have done nothing else to it. And rather than using printers, I'm just using, bare printer boards. Fortunately, these will all back power, so they'll all be detected when I plug them in. So, the steps that you would take to do this. You do have to install Git, and I'll show you how to get this, and it tells you how to make sure that you have Git installed on your system. But you will clone OctoPrint deploy from the address that's here. So now you have this established. You do have to use the sudo commands because these are modifying system files. So we would give this OctoPrint deploy deploy.sh. Password. And the first thing, as I mentioned, that we're going to do here is we're going to prepare the system. So we just click 1. It's going to ask us how we're set up. So this is compatible with Octopi. So if you're using this with a Raspberry Pi, you've already flashed Octopi, you can use this here, or it gives you different Linux flavors, essentially, that you can choose. I'm on Ubuntu, so I'm selecting 2 here. Asks if we're ready to begin, and as it tells you, this is going to install all the necessary packages that you need. It's going to install OctoPrint, and then it's going to set up this template instance, though it seems to be going kind of slowly. There we go. So this is now the OctoPrint installation that's happening. And As I mentioned, this will also allow you to set up hot proxy. So we'll just say yes here. It'll also set up a web streamer for you. So the options you have are MJPEG streamer, which is standard for Octopi. But I would recommend if anybody's doing this to use MicroStreamer. It's much better. It's Ustreamer is how it's spelled, but you say MicroStreamer. So 2, it'll actually clone that, build it, and get that going. And the good thing is that I'm not going to use up all 30 minutes, so there'll be plenty of time for questions if you have any when we're done. It's now going to ask if we want to set up that admin user now. We'll just say yes, me. You have to give the password here. Right now, this is still in plain text. I can change that later. If we want to do the first run wizards, we'll say yes, online connectivity, etc. We can install some plugins now if you want. You can install my plugin, cancel objects, but install all the good ones. We'll quit out of that. It'll also let you do some of the cloud service plugins, Octo everywhere, Simply Print, all those things. I'm going to say no, we don't need any of those for this. And now we're ready to put in new instances. So I'm just going to select one here. We're going to give this a name. We'll call this printer 1. And now it's going to use, if we just say used, we can change things here if we want to, but we can just use all default values, and we push yes. And now this is the point where it's going to ask us to plug in the printer via USB. So we're going to do auto detection, and this should time out in about 1 minute, unless we plug in a printer, which I'm trying to do. So you see, it automatically detected the serial number of the printer, so that UDEV rule is now established. So that OctoPrint instance, printer 1, will always be associated with this board. It'll now ask if we want to do a camera, and I have one here, so we might as well do it. So serial numbers detected. And this is a point where there's not a lot I can do about this, but there is a lot of manufacturers don't put unique serial numbers. This serial number is SN0001. That can end up being a problem in some cases. So you do need to look out for that. And it will alert you if it detects duplicate serial numbers. We can set up the resolution here for if we want, in this case, MicroStreamer. This is using hardware encoding, so we'll give it 0. And now this is the point where we're about to finish the instance. Do we want to write all the changes and continue, or we could just quit out if there's something we don't like? We'll say yes here. And this sometimes takes a little while for reasons I don't fully understand, but here you can see that we've created service files. So these are things that are automatically going to be started at boot. So we have something called printer1.service, and we have camprinter1.service. So those things will always be started, and they will always be associated with this camera and with this printer. I think it's the hot proxy that takes a little while here to go through. But it's also just this computer. Any questions while we wait? My recommendations for hardware would be whatever you have sitting around that can run Linux, right? Because really that's all you need in order for this to work. Let me do one more thing. I'll have plenty of time for questions, so you'll get some more. But I just want to show you that this can be fast. So I'm going to do just another instance here. We'll call this printer 2. Use defaults. Auto detect. I don't have any more cameras. And we could keep going with this if we had more printers that we wanted to use, but at this point we don't. There's other options that I'm not really going to talk about here. You can make backups and things like that. But now let's just open a web browser and connect up to those. So in this case, oh, I forgot new Firefox, you have to give this in there. So we can go to localhost, and because we use HA proxy, we can just call this printer 1. You do have to use the trailing slash on this. But if we connect up to that, I did this once before to make sure that the logins will work. And there's our printer 1 instance. You'll notice also that the serial port here is automatically named. So that will know that it's that first board that we plugged in. We can auto connect, save the settings, connect up, and if we look at the terminal, I should have set the baud rate. While that waits, let's just go to the second instance. Oh. We have a problem. I told you it was a live demo. You never know exactly what's going to happen. Of course, yeah, exactly. So here's our second printer instance. I don't know why it wasn't accepting it before, but we can connect to this. There's our terminal. You can see that we've got the printer connected up. What I'd like to do is show that the camera's working too here. All right, I just had to set the baud rate. But you can see we have the printer connected up, and if this worked correctly, our camera's automatically set up as well. So, all right. I have a few minutes. I have a couple more things to tell you about here. There's a lot of naysayers to using multi-instance OctoPrint, because one of the things they like to say is, well, if your computer crashes and you're printing a bunch of things, they all crash. I would say that's absolutely true, but you are able to prevent that. If you're running a modern, semi-modern computer with a semi-modern Linux distribution, it doesn't crash. If you're using a Raspberry Pi and you have lots of problems with crashes, get a new SD card and get a new power supply, because they should not crash regularly. It may happen occasionally, but if you're needing to run 7, 8 printers, spending the potential that you lose a couple of prints because you get a crash, it's probably cheaper than having to buy all of those Raspberry Pis that you'd be interested in. The other thing is power consumption. A lot of people say, well, if you run OctoPrint off of like a laptop like this, you're using so much more power than a Raspberry Pi. I've done the numbers, and it takes about 2.5 instances on this computer running headless compared to having Raspberry Pis. So basically, if you run 3 instances on this, you're doing better power-wise than you would if you had 3 Raspberry Pi 4s with their own power supplies. So it's not hard to overcome that power consumption issue. There are other things to do, so putting cameras behind hot proxy, allowing multiple cameras per instance, which already exists, but I don't really like the way things are going with that yet, as well as doing things like automate application keys. So if you want to be able to send directly from your slicer, you can do that at the time of setup for those instances to make it a little bit easier. How to get, so GitHub repository is how you get this and use this, but also as of like last week, you can find links for this on the OctoPrint download and setup page. And the last thing I'll just point out is that a user of OctoPrint Deploy was asking me, how many printers can you use on a Raspberry Pi 4? And I said, I don't really know. I've done 10 before, but I didn't really do any metrics on it. So user by the name of Steg, they have a Raspberry Pi 4, 8 gigabytes, 12 instances of OctoPrint connected up to 12 instances of Prusa Slicer, to Prusa Minis rather, and they are using the SimplyPrint cloud plugin. So this is CPU usage when they uploaded a file to all 12 of those instances where you see everything pegged out here. That's the OctoPrint G-code analysis running on all 12 of those instances at one time. But everything after that, where you see just a few spikes, is all 12 of those instances printing simultaneously on that Raspberry Pi 4. So you can do quite a bit with it. All right, that's all I have. I know some people had some questions, so I will try to answer those in the next 4 minutes. Dom. You absolutely can disable plugins per instance. So if you wanted to run Clipper on one instance and you wanted OctoClipper on one of your instances but not the others, you just go into those other instances and turn off OctoClipper. And then you don't have to worry about it anymore. You had a question? Yeah, so if like a Raspberry Pi 4 is only going to have 4 USB inputs, so in order to run those other printers, you have to use a USB hub. The only cautionary thing with that I'd tell you is that if you use printers that do not have serial numbers, the hubs have to be in the same position and the printer that's plugged into the hub has to stay in the same position of that hub. That's the only caveat that you have with doing that. Anybody else? If you have other questions that you think of, just catch me as I'm wandering around. I'd be happy to answer them. Thank you.
Just go. Hello, everybody. My name is Sam Prentis. Oh, hello. Are we good? 1, 2. Check, check. 1, 2. Hello, hello. Hello. So I thought this talk was actually at 5 o'clock today, but apparently it's at 4:30, so apologies for that. Come on in. Take a seat. Thank you. We're good. Okay, so my name is Sam Prentis. I'm involved with a number of robotic projects, which has sort of bled into a number of different areas, which has included 3D printing, film, TV, and even into things like today, the death races, which you might have seen outside, which again, thanks to amazing people that have been involved with that, which has been pretty good. So my background, as I say, I'm a YouTuber now, but that's kind of like just a bit of a fun job that I have on the outside. But the robotics, the droids, and the 3D printing does blend together very, very well. So I just wanted to go through a little bit about what my story was and how I became sort of who I am and what I guess the path is on leading up to today. So I was involved a few years back with the last Star Wars film, which was Episode 9, The Rise of Skywalker. It was quite a privilege, actually, because I'd built a couple of droids, Astromechs R2-D2s for the films. Can you guys hear me okay? Yeah, cool. Okay. So all of a sudden, I was thrust into this limelight of building a droid called R2-SHP. And SHP stands for Sam Hannah Prentice. Hannah being my wife, not my middle name, because that would be weird. Off the back of that, I spent about 6 weeks on set, which was the most amazing 6 weeks of my life, because working with actors and actresses that I respect and have seen on TV and film just kind of blew my mind, because I was in amongst this whole kind of weird definition of people. Then something really great happened. Disney then decided to manufacture toys of my droid, which they sold at Galaxy's Edge and sold across the world, and made special edition cards, Topps cards, and all that kind of stuff with essentially my name on it. I didn't get any royalties for that, but I kind of felt like it was a bit of a cool thing to have happened. That being the case, though, it kind of put me in good stead with Disney, and I'm outside of my NDA now, so I can kind of talk about pretty much anything, so that's kind of cool. I built 6 R2-D2s in total. As you can see on the right-hand side there, that is me on the blue carpet in London. We did that event. We did a press junket. We did a makeup party with R2-D2 and C-3PO of all of the bizarre things. We did Children in Need. We did an event with a guy called Graham Norton, who's a talk show host in the UK. And again, you end up in these positions where you feel like almost like an imposter sometimes. Like, why has this happened to me? What have I done to deserve this? And I know in certain terms, I didn't feel like I really kind of deserved to have the things that I had. And to be honest, I still don't, which is kind of maybe a bizarre kind of admittment to how I behave and how I hold myself and stuff like that. But it led me into dealing with things that I didn't expect to deal with, like companies that did 3D printing. Now, there's an interesting element of 3D printing because, believe it or not, a huge amount of props that are made for film and TV are 3D printed. Now, the droid that you can see there, the blue one at the front, was a 3D printed droid that I made for the film. And that was called R6LE5. Now, as you can see there, R6LE5 is a 3D printed R6 dome. And you see J.J. Abrams there. So what a lot of the time they do in film is they print something and then they will cast over the top of it. J.J. Abrams said, I really like what you've done with your robot. So this is a big deal for me because I've got a major Hollywood director telling me that they like what I've done. And I'm just some guy off the street, let's be fair, right? There's nothing special. Anyone could have done this, but it just so happens I've managed to align myself with this kind of situation. So what he said to me was, let's get you on set, let's do some cool stuff. And this is me on set. And this is kind of embarrassing. Look to the left now. There I am. Yeah. Kind of embarrassing. And luckily they weren't filming at the time. But again, I'm in a forest scene there. And Jonas, who plays Chewbacca in the film, he was acting out. It was a good time show. But what JJ said to me was, R2D2 really shouldn't be should be the only one with a dome. So I quickly got my CR10 S5, and over the period of 9 days, very, very quickly, got some really awful pink filament and printed this thing up. And he wanted an R6 dome. In fact, I think this is probably the wrong dome, but you get the idea. After the show was done, after the film was done, COVID hit, and we were all having hard times. My wife was expecting a baby, and I went to Lucasfilm and I said, hey, you know what? I want to sell my droid. Do you want to buy it? And after a few days, they said no. And I went, okay, because they didn't have the funds in place to do it. So I went to Prop Store, and bear in mind that dome that you're pretty much seeing printing there, it cost me £10 to fabricate, 10 British pounds. And I then went to Prop Store, who then went on to sell it for $12,500. So return on investment for 3D printing here is kind of a, I don't know, it's kind of a good thing. I also sold the full metal R2 as well, which went for a lot more money. And I didn't quite expect to see, as you can see there, the live auction. It's got a picture of my droid. It's got Jason from Friday the 13th, Harry Potter's glasses, and Harry Potter's wand. So you all of a sudden get this kind of realization that you got your name in the credits, you've built robots for Star Wars, you've sold stuff and you've made some money on the back of it, and everything kind of comes to an end. And whether or not you naturally engineer that end, or ultimately, if it comes to an end by accident, everything comes to an end. So kind of my Star Wars days were kind of done. I started doing this YouTube stuff, and all of a sudden, we get to a point where we start talking about death racers. And I've got to say to you guys, death racers for me, again, there's going to be a start, middle, and end to this. The start was several months ago when I met up with Joel Telling in Germany, and we decided to try and make this thing happen. Then Polymaker jumped on board. Thank you once again to Nick and his team for just being so bloody awesome. It just blew my mind. All these death racers turned up today, and the premise of death racers is it's a small radio-controlled tank robot. And the idea of this is you knock your competitor's head off. If you saw it outside earlier, there was a ton of people out there. It was epic. And I was just saying to a few people earlier, there was a moment when I was sat there and I was just thinking about what I'm going to say and how I'm going to introduce these things. And I looked at the amount of effort that people have put into these droids and these robots, these battle bots essentially. And it sort of choked me up a little bit, because you soon realize that this is a community-led thing, and 3D printing is so important to so many people that sometimes you just forget that, I don't know, it's kind of weird to say. It's kind of like this is what they've got. They've put their time and effort into that. And why have they done that over something that myself and my team have managed to create as just a kind of thing that we thought would be fun? Then we come to America. So I've flown in a 20-hour drive with my buddy Tripod down there. Thanks for driving, buddy. And then also an 8-hour flight from the UK to the US. And it was all just so worth it for that moment to stand there and go, this is going to be great. And it really, really was great. And I've just been talking to Nick upstairs, and how do we evolve from this? How do we move forward from that? What's next? What can we do that's going to be even bigger, that's going to be even better? How do we get ourselves a product out there that's going to just be epic? And it's something that's really sat on my mind, and especially with the start, middle, and end ethos that I have here, because the Star Wars thing was, one of those moments where it's kind of like, I can't believe this is happening, but you've also got to be realizing that nothing really lasts forever. And I think you've got to take the best of a situation, deal with that situation, enjoy the situation, and then move on. And I think that's pretty much how I've kind of led my life, which is a bit of a weird thing to say, I guess, but I'm almost like having an epiphany up here. It's weird, right? I'm kind of like, hey, you know what? I was this guy in Star Wars, and this is what's happened, and blah, blah, blah. And now I'm here in front of you guys in America talking about a thing called a death racer. It just seems to be really bizarre. So that's my background. That's what I do. I'm a robotics guy. I love 3D printing. And over the last 10, 20 minutes talking to Nick from Polymaker, we were talking about the community and we were talking about people and how they hold themselves and how humbling this whole situation has been, especially with you guys down there, because we talked afterwards. And it just, I don't know, life is about experiences. And I think once you get past the notoriety of perhaps trying to be something you're not or trying to be somebody you're not, and then you realize that there are bigger things out there, such as, I don't know, I do a lot of charity work. I'm able to give back. I do a lot of charity work with the Droid builders. I'm a committee member for the UK R2 Builders Club. I do all this work, and I'm non-stop all the time. And it just dawned on me today that I'm with a bunch of people here that are just so entirely awesome. So thank you guys for being involved with this. And if you've got any questions, if you've got any, anything you want to ask me about robotics and design and stuff like that, please ask away. But I guess that's kind of me. So thank you very much. There you go. Come on, tripod, let's have the question. How bad was the trip here? No, the trip wasn't too bad, to be fair. Go on then, Jim. I didn't. Yeah, that's a good one. So, with any kind of electronics project, and I found this certainly this year with Mirth and Earth, we really rushed to get the last lot of races out, and we thought we had time, and you never have enough time. And I had the best in the business, basically trying to look after and work my stuff forward today. But sometimes it just doesn't work out, and I'm gutted. I'm honestly gutted that I couldn't race today. Yeah, maybe I'll do Lusport tomorrow, right? We'll see what happens. But I was gutted that that didn't happen. But again, in life experiences, I think you've got to be able to kind of go, okay, well, that's not going to happen, and not get too dejected and annoyed by it or peed off. So I'm glad you won, dude. You didn't deserve it. That's all right, man. Yeah, no worries. Yeah, fire is our worst enemy in this business, right? No problem. No problem. Any questions, Star Wars related or not? I don't mind. I have 52 printers. You didn't know that? You need to send me your filament, man. How many droids? Probably 9 at the moment. So I'm constantly evolving, I'm constantly doing different things, and I don't like, as I say, I don't like to get stuck doing one particular thing, which I think is why we got a good relationship with Polymaker, because, you've got to move on, you've got to try something else. If you stagnate and just do the same thing time and time again, you've got to kind of move forward from that, and you've got to evolve. So there you go. Yes, sir. Say again. When I get back to the UK, I'm probably doing Andor, the second series. Yeah. So the problem, so what happened was with that, it's quite interesting. So the Rise of Skywalker and COVID didn't mix particularly well. Okay, there was a ton of Disney shows that were supposed to come out and supposed to be filmed in the UK because Disney pretty much bought up all the time at Pinewood Studios. So I was like, yeah, this is me now. I'm just going to be this dude in Star Wars. I'm in the team. This is amazing, right? And Obi-Wan, Andor, the TIE Fighter series, all that stuff was supposed to be, sorry, the X-Wing series was supposed to be filmed there. And it all just went away really quick, which sucked. A lot of the stuff that you'll see in The Mandalorian and the Obi-Wan, that was flown over from the UK studios to the US studios. They were repainted and reused basically for that. So, but Andor is still with the UK, thankfully. And yeah, they're getting ready to get into pre-production over the next couple of weeks. So I'm still very much involved with that situation and sitting on the committee and the clubs and all that kind of stuff. But fair's fair with this because there are people that are involved with this in a very heavy way that do a lot of charity work and things like that, which are part of the R2 Builders Club. And we want to make sure that they also get that experience of being able to go on set and have their names in the credits, if that's what they feel is important, great, all power to them. Don't get me wrong, I want to get back on set, right? I will fight to the death to get back on set. But it was an amazing experience, and you're in Star Wars. There's no two ways about it. I was chatting to these guys earlier. I was on the set with where, spoiler alert, Princess Leia died. The Tantive 5 ship was above my head, and I'm sitting there, and Billy D. Williams walks in, Lando Calrissian, and I walk up to him, and I'm stood next to him with my radio control because I'm cool. And I was like, I just want to, because the deal on set is you're not allowed to talk to the actors, okay? So I walk up to Billy D. Williams, and I'm just listening to his voice. And these are the words I heard him say. The lady comes over, his assistant, hey, Billy, what do you want for lunch? And he goes, yeah, I'll have a salad. And I was like, that's enough for me. Thank you very much. I know Lando Calrissian is now having a salad. I'm going to move on now and see what else is going on. But yeah, Daisy Ridley, John Boyega, all those guys, and to just be someone that's appreciated and loved Star Wars for a long, long time, and then finally, growing up with it throughout the 80s, and then actually be part of the film was, for me, just insane, or phenomenal, as Jim would say. But yeah, so we're back onto it anyway. But the thing is, you'll never see the end of Star Wars in your lifetime now that Disney owns it. So the mouse is key there, It's a good thing. It's a good thing. But again, BB-8, it's 3D printed. And then they cast the dome. Dio, that wasn't 3D printed for the film, but because it was actually puppeteered. But for the red carpet event, a really, really talented engineer called Josh, he made Dio. And I was out to dinner with them in Chicago, because it's a few years ago, and his wife was there. And I said, how is it living with this absolute god of robotics? And she was like, I'm sick to death of that printer going all night long. All I can hear is this wah, 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 wah. And he uses a Prusa. So there you go. There you go. It is what it is. Sorry. Awkward. I'm just glad Joe's not here. It's all good. It's all good. Yeah. Oh. So there you go. Yes, sir. I can't hear you. Sorry. So the robot designs, I coordinate with a guy called Michael Badley. He's got a Patreon site, and what we do, the relationship's pretty simple. Mike is kind of like a mad designer, but I'm very much the hype guy. So I'll bring him up drunk and go, hey, Mike, what about if I was able to have a fist fight with Joel Telling? And he goes, right. And I go, but I like the guy. I don't want to punch him particularly, but what about if we had a fist fight and it was a robot and it wasn't Star Wars? And the way that came to be is there was a small robotic thing that we were going to put out and then didn't for a number of different reasons, but we had a track drive system, okay? So we then kind of engineered this whole thing around actually Rock'em Sock'em robots, Robot Wars in the UK, BattleBots in the US. How can we do this, and how can we merge that into a 3D printing culture? So the designs are kind of just made up, but the great thing is about the community, and that's really, really key again, because the community and what they've come up with. There was someone walking in with a coffin earlier, and that's what they put their BattleBot into, right? Like, I don't have to think anymore because people are just doing it, and the results off of that have just been amazing, absolutely amazing. So thanks for your question, though. Anyone else? What about you, sir? Nothing on you. I'm keen to get questions in now. Okay. So I'm going to tell you what's next, because we're going to do it. You've already seen it. We're going to have flying death racers. There's going to be 2. Me and John are going to do them for next year, and it's going to be an exhibition thing, because we kind of think that it's going to be too dangerous to kind of have, but we're going to do it. We're going to do that, and then we'll see what happens with the death racers next. Yeah. We haven't seen each other since I went upstairs to edit this together, and now, So we're going to get some flying versions in next. And if anybody does want in on it, then let's talk about it. Okay, I see some hands being raised up. Okay, So I'll tell you what we'll do. We'll reach out and we'll talk about it and just look at the fundamentals of stuff. Sorry? Who was it? Oh, don't worry about him. He doesn't even know who I am. So good. Any questions? Any last questions? Not even about Star Wars. You're not even a Star Wars fan, are you? You're Star Trek. You do look like a Trekkie, to be fair. I have to say it, dude. Yeah. Well, again, thanks very much, guys. Appreciate you coming out, and we'll see you next time. All the best. Boo-hoo. Yeah. Thank you.
Hello, hello. Let me That's way too far down.
Run, Claire, run!
Howdy, everybody. How's everyone doing? They put me on last, so yeah, we get to chat and stuff. All right, hi, I'm Matt Stultz. I do stuff at Prusa. There's Joe. Wave, Joe. Joe didn't want to get on stage, but we're still going to embarrass him for a second, so all right. Yeah, so Printables, past, present, future. Yeah, so for those of you that are unaware, print a what? So Printables used to be Prusa printers. We were here 3 years ago, the last time we were doing this, and I was like, hey guys, you should like check out Prusa printers because it's super nifty and Thingiverse sucks. And guess what? 3 years later, Thingiverse still sucks, but Prusa printers is a hell of a lot better. And we are making the community that this community needs. It's not just a repository for your stuff. It's everything. We've got groups, we've got events, we've got places for you to show off your models, follow your favorite designers. It's fantastic. Raise your hand if you're on Printables. All right, so I'm preaching to the choir here. All right, we're in good shape. Great, awesome. So let's talk a little bit about Printables timeline. We launched Printables in April of 2019. Yeah, that went great. We introduced Printables here in Q4, October of 2019. We also, around that same time in November, launched our very first, no, I think it was actually October, because I think our first design contest was a Halloween contest. So yeah, so we launched our first design contest. This is still low, sorry. I feel like I'm like, all right, I'm better, something. Yeah, so launched our first design contest. Prusa printers continue to grow, expand, everything else. Then this thing happened. I'm sure you all heard of it. It was called COVID. And everything sucked. And we all stayed at home. But a lot of us turned on our printers and said, hey, let's print these face shield things that this guy named Joe and his team designed and put on this little site that we were all calling Prusa printers. And so, yeah, we got a lot more traffic of people coming in, downloading face shields, making face shields, but we said, let's find ways to coalesce those people and make it easier for them to chat about what they're doing. So we launched groups to support COVID. Groups are still there. They're not as heavily used, but I think we should fix that. I think that's one of the things that we, like all of us, should do. Like, we should find other reasons other than face shields to make like printing groups and do stuff. Like the Death Racers guys that were just here. Why aren't there Death Racers groups on Printables? Like, people can chat and discuss things about Death Racers. It'd be great. So that moved forward. Printables kept on expanding. And then we released rewards, and you guys loved that shit. Sorry, children. Yeah, so we'll talk about some numbers here later, and I bet you'll figure out when we launched rewards. So rewards, you guys know, you're able to earn Prusa meters for uploading your designs and people downloading your designs and your makes and everything else. And rewards have been going crazy. They've been going great. How many spools? Can we say how many spools people are? Yeah. Yeah, like 200 spools a month are going out to you guys from earning spools. So, yeah. I mean, that's on you guys. Like, you are earning them, and we appreciate it. So it's fantastic. So yeah, things have been going like a rocket for all of that. In January this past year, we launched Flash contests. So now, instead of just having a contest every month or every 2 months, there's a new contest coming out every single Friday. It drives me crazy. I shouldn't have come up with this idea. Thursday night, I'm up at midnight launching a contest every Thursday night. I asked these people on this Friday night call thing, what should we do next? And so, yes, if you have any ideas for Friday nights, or for Flash contests, I'm running out of ideas. I need your help. I need the community's help to come up with more Flash contest ideas. Then finally, also around January, we finally got rid of this burdensome name of Prusa printers. Prusa printers are fine, but everyone got confused. They're like, but I don't own a Prusa. It's like, well, you should fix that, and B, it was good for any printer. It didn't matter if you had a Prusa printer or not. Any printer, it still worked. But we got the ultimate name, Printables. Printables launched. It's fantastic. Joe went through all kinds of negotiations. There was this. Can I tell the story of where I came? Yeah. Okay. There's this guy out in like Seattle, that owned a print shop, like screen printing T-shirts. And like in the beginning of the internet, he said, I should register a good domain for my print shop, and he registered Printables. But he kind of like realized his little tiny like in a strip mall screen printing shop was wasting this really awesome domain name, and so he was willing to give it up. He's probably living well now, but he was willing to give up that domain. So eventually, Printables changed. You'll see ticks in our data too that people definitely responded to the new name very well. This stage, I gotta say, I went to this thing a few months ago that was dog dock diving, and this feels the same thing. Like I'm just supposed to jump off of this thing out to you. Like this is awkwardly tall. Anyways, yes. Yes. Now, latest development community feed. Like I say, you can now start following your friends, your favorite designers, see what they're printing, see what makes they're coming. You get a nice little feed like you're on Twitter or Facebook or something like that. So there's a more social aspect to Printables coming. So what does this all add up to? We're constantly developing. We're constantly pushing Printables. There's new things always coming. Where other sites, Thingiverse, are just sitting stagnant and dying, Printables getting worse. Printables is moving forward. We're creating new features for you all the time, and we'll get there. Growth of designs. Did anybody else get the wave? I get the wave. See? All right. Can you guess there when we launched rewards? You guys responded really well to that. You see a couple other blips in there too of the rename and flash contests and things like that that really upped the number of uploads that were going on. So rewards worked really well. I think it's also interesting when you correspond to users, because users are still going up, but users are a lot more steady than the design uploads. Claire's giving me a dubious face. Listening? Okay. I think when you look back and forth between these two, you can see that like it's not just we got a lot more users, the users started making a lot more things, right? You guys really started kicking in the designs that you were uploading, which is fantastic. This statistic for all the like nerdy like web nerds out there, I kind of think this is awesome. So September 2021, we're seeing 2.6 million page views per month. By September 2022, 12.7 million page views per month, 4.9 times increase. I'm getting faces. Andre said I can say this. Okay. Andre sent me the data. All right. So, but what's next? Like I say, we're always expanding. We're always creating new stuff. I know you all want to know the secrets. Everyone comes to these things and says, yeah, but like what's next? All right, partners. So we are going to work with more companies so that we can better highlight the things that they are doing, as well as make it easier for all of you to find these things and find things from companies. We're gonna drag the rest of the world, all these other industries into the 3D printing world, kicking and screaming. But we're gonna make it happen. Frank's starting. So you volunteered, right? You're waving your hand to volunteer. We're getting UPS on board, right? Okay, all right. So partners is coming. Designers. We're talking to some of your favorite designers and Wexter to come up with ways that we can support designers better. We know that, you know, there's plenty of things that the community is developing that are fantastic, but we also know that there are some individuals out there. Wexter Fotis is here. Neil 3D Prints. I'm blanking out on people I want to talk about. They're just knocking it out of the park, and we want to make sure that those guys are just as at home at Printables as everyone else is, and that their work is really being highlighted. So more is coming for designers. I know I'm vague, but some of this stuff I have to be vague about. So what can I show you real details? How about analytics? One of the things that users have been bugging us almost from the get-go from is like, how are my designs doing? What does this, you know, are users downloading my stuff? When are they downloading my stuff? How, you know, who's liking it? You know, what's the deal? I need data. And so we've been holding off a little bit, but analytics are coming. I promise you, analytics are coming. And here's the proof. So this is a screenshot real quick. This is just a few data points of what it is, but metrics, analytics, all coming in. You're going to have, did I get quiet? You can hear me, right? Oh, okay. I heard an echo before, now it went away, so I just want to make sure. Okay. So yeah, so analytics are coming. This is just a screenshot. There's a lot more in there. That's a scroll down. But yeah, we've got analytics. This is my last slide, but Joe reminded me, the other one for, again, all you nerds out there, dark mode. We're getting dark mode super soon. So all of you that are on Printables into the wee hours of the night will be able to spare your eyes at least a little bit. But yeah, lots more coming, lots more developed. We love you all for being a part of this. Like, it doesn't make sense if you guys aren't uploading stuff, so and downloading stuff and sharing things. So, you know, this is where my passion in this whole thing comes in, and so I really appreciate that we have this community that's building this. So now I will take questions. Are there any questions? Oh, gentleman with a V. All right, yeah, we are going to need to do this mic thing.
Look at this, a fancy microphone. So you have all of this beautiful data here, and you have a whole bunch of people who are putting models up and taking models down. How do you guys, like, why are you doing this? How are you making money off of this?
Some things are more important than money.
Okay, so is this just a loss leader for Prusa?
And so, like Joe, like, he's a pain in my butt, but he's an awesome dude. Like, the things that he does for this community that people don't even know about, like, because he doesn't take credit for, is amazing. And Printables is out there because the community needs it. The community needs a place for this to be shared. And on top of that, like, a lot of us that came from the old days of 3D printing, the old days, 10 years ago, there was more of an idealism in 3D printing back then of this concept of sharing, of open sourcing the world. And, you know, that is something we want to see live on. And that is not something that, like, if Thingiverse were to die, I think even if Thingiverse were to die today, because we aren't quite there, we need to keep that momentum going. I think we would lose a lot of that in the community, and I think we are losing a lot of that in the community because of other things. But it's very, very important to a lot of us, and Joe most importantly, that aspect, you know, maintains, that aspect stays. So Printables is more about an ideal than money.
Okay, and so the Prusa is just willing to write that off and eat it?
We're giving away 200 spools of filament. Like, we're not just running this thing, we're giving away product that we could be selling because we believe in this so much.
All right, thank you.
Yeah. Frank.
So to follow on to that comment or question. With the the cynical side, is there any plans to add the ability for creators to monetize their models onto printables?
See that designers tab.
I didn't
Secrets.
get that from that. But
Secrets. Anyone else? Monica? Monica, do you have any questions? Are you sure, Monica? Okay. This gentleman raised his hand.
So when you upload a model, it basically forces you to provide a picture?
Yeah.
Is that, I'm just curious why. I mean, because sometimes I make something, but I can't print it out because of...
Yeah, I mean, there are people that will take screenshots out of their out of their design software or out of Prusa Slicer or something like that to do it. But what we find is that those models are not as successful. And one of those things is a picture, and the makes even further. Like, you guys as a community contributing back makes take things to an even further thing, because what we find is most people want to print something that they have seen printed, because especially those of us, in the when we first got started, there was probably a chance that you got burned by downloading something that you didn't realize wasn't printable, but it wasn't printable. I mean, Thingiverse is absolutely chock-a-block full of just unprintable crap. And when you look at a thing, a design, and you see a picture of the print, you get a better idea of, oh yeah, that's how this thing's going to come out. It is printable. So we try to encourage people to upload the images of the actual printed thing so that others get the idea that yes, this is indeed printable. It's worth my filament. It's worth my time. Gentlemen, okay, we'll get back to you.
Hi, how many total models do you have, and what do you expect to see in the growth rate going forward?
I'm sorry, Nick, could you repeat?
How many total models do you have?
How many total models do we have? I looked last night, and well, actually, do you guys want to know the secret to find out how many total models we have? Because you can all find out anytime you want. Yeah. So go to Printables. Go to the models, go to newest, and click on the newest model, and the ID number at the top of that. Oh, it's printed? Oh, I missed it. Mickey says it's printed on the site. Anyways, it's around 250,000, a little bit over 250,000 models.
What do you expect over the next year?
What do we expect over the next year? To the moon. Yeah, it doubled in 6 months, right. Yeah, we celebrated 100,000 models in January or something like that. And we're already at like 250. So every time we're like, oh, we should do something about like something big about the next milestone of models, we're already past it by the time we get to it. So 1 million, we need to plan ahead of time and keep track. It's not too late. We're at 250. We're a quarter of the way there. We'll be there by the time we're talking at Murph next year, if you guys do your jobs. So, all right. This gentleman down here, white hair, he had his hand up.
Thank you. What you asked earlier about crowdsourcing ideas for the Flash projects. I had an idea that I wanted to propose, turn the tables just a little bit, a challenge to you guys. Photovoltaic printing. I don't know if there's any kind of filament out there that can handle that, but it's just an idea I wanted to throw.
Photovoltaic filament?
Yeah.
Yeah, I mean
that's a challenge to you guys, not for the Flash crowd, but
yeah, that'd be neat. I mean the Prusa guys are wizards. They're always working on something. I won't promise anything, but they're always working on something nifty. So
yeah, I know they're brilliant, so I wanted to throw it out. And
yeah, I'm here to talk about printables, but man, Prusa, we got some cool shit coming. It's not photovoltaic, I'll say that right now, but maybe someday. Does anybody on this side, so we can make Nick run again, have a question? Oh, Sam. Shit.
Um,
How many kids are in here? I'm sorry to the parents. I'm potty mouth, and I'm going to enjoy it. So.
Is there a leaderboard on Printables so that people can be in the top 10, top 20 in the world and in their like country for who has the most
You know that
makes
Sam
and
was
who
going to
has the
ask
most
something evil.
designs? Because we're a competitive community.
Hey, Mickey, you sit beside Andre. Let's make this happen. Leaderboard.
It's already on the list.
Okay. All right.
We're getting through to.
Yeah, Sam has to poke the bear. She always does. So, yeah. All right. Awesome. Amos. Someone over here, get an idea ready. Come on.
So, Prusa Slicer just got support for step
Amos,
files.
come on. Talk louder.
Prusa Slicer just got support for step models. The viewer, as far as I'm aware, still displays SDLs. Will there be step file support in the viewer?
I think I understand what your question is. Yes, we have now started to accept step files, but it does basically convert them over to a surface mesh. It's not maintaining a solid.
STLs right now.
Viewer. I mean, when you import the step file, doesn't it just show up? Oh, on the site. Oh, that's a good question. Yeah. Sorry. My mind switched instantly over to Prusa Slicer because you said Prusa Slicer does this, and so yes, on the site. Yeah, probably. Yeah. I'm sure Mickey's saying it's on the list. The list is big, which is also great, right? Like, we have this giant list of new features that are coming because we're constantly developing and making it better. So, yeah. Andy, what's your question? We got to make Nick run. Just so everyone knows, Nick's my neighbor. He lives 2 doors down from me. Like, this isn't a joke. Nick lives 2 doors down from me. We have dinner every Sunday night. His wife, who also is one of the organizers here, and my wife, who's sitting over there. So, like, I will pay for this later. It's fine.
What is your favorite group currently?
On groups?
Yes.
I mean, 3D Printing Pittsburgh, of course.
Thank you.
Chris and Ryan, what up?
Follow up, what is your favorite current music group that has nothing to do with this presentation?
I mean, it's always Bad Religion. Over here? Come on. You all want to see it. All right, you're close enough. We're going to the center. Left of center.
Can you talk more about the groups? Because I saw it but never used it. And
so groups provides more of again, like a central hub for a community where there are messages. People can leave messages. They can make announcements and things like that. And again, I'd love to see us develop that a little bit further. I don't think it's probably has a lot of priority right now because it has dropped off of COVID, but I would like to see a shift on that. But really, it's just a way for people to message within each other and coalesce around things. Again, like, what's my favorite group? So 3D-PPGH, 3D Printing Pittsburgh made a group when they were doing all of their face shield printing stuff, so they could let people know like what efforts that they were doing. People could discuss there. They of course moved that mostly to Discord and things like that for real communication or major communication. But it was an easy, almost like classifieds kind of way for people to find that there was something going on in that area. So if you are in an area, check and see if there's a local 3D printing group that may have started from COVID in your geographic area, and see if that group can be repurposed for something else, or start a new group altogether. So before this whole COVID thing happened, one of the things I used to do for Prusa is I would travel around the country like Johnny Appleseeding, starting local groups of like 3D printing meetups. So I used to live in Rhode Island. For 7 years, I ran a 3D printing meetup there, and then I joined Prusa, and I was like, let's do this everywhere. And so I would someone would have a maker fair, and I would show up at their maker fair and be like, I'm buying pizza and beer. Let's talk about printables, and why don't you do this all the time? But then COVID happened, and best laid plans. So, Mickey.
How do I get my...
Well, hold on, wait. So, yeah, so start local groups. There, go ahead.
How do I get my
That looked dirty.
event visitor badge? How can I get it?
How can you get your visitor badge?
Yes.
Yeah, very important question. So all of you are here right now. If you haven't gotten it already, you can earn a Printables badge while you're here. We have a banner right outside of the Cocoa Press booth, right outside of our booth, has a QR code on it. You scan it, and that will get you a new badge on Printables that goes into the whole like rewards and badging system and things. So make sure to scan that. Woo! Is there a keyword every time I say Printables? No? Okay. Billy.
When is your...
Whoa!
Sorry, everybody. Is this acceptable? Is this okay?
I can't hear you now.
How's this?
Nope.
No? Yeah? Here?
Yeah, okay, we're good.
Holy. When is your real favorite group going to get a group on Printables, the Friday Call group?
Oh, that's a good point. We should do a Friday Call group
We should do a Friday Call group.
Yeah.
Yeah.
Good point. I'm a slacker. So, yeah. Also Friday Call. If any of you guys are like sitting at home bored on Friday, 9 o'clock Friday night, like we all hop on Zoom and chat about all things 3D printing and maker stuff. Raise your hand if you are a Friday caller. Yeah, see, there's a bunch of us. We had dinner last night. There was like 40 of us. So it was awesome. You could raise your hand. Oh, I didn't miss it. Okay. There is a 5-hour time difference. We have this crazy guy from Sweden who stays up all night so he can be on the call. It's wonderful. Eric's the best. And he has, never mind, I'm not going to talk about his chair. Yeah, Maker Viking 2, that's right, yes. Yeah, so we've got two, of course they're from Scandinavian, two crazy Vikings that stay up all night and join the call. Like, often they leave the call and they're like, here's the sunrise. So, yeah. Questions? Someone? Oh, Mickey again.
It's not really a question, but I'm just going to hijack a little bit.
Good. I mean, you can come up here.
Yeah, I could. I'm just going to do it from here.
You can come up here topless. P.S. I asked him if he wanted to participate months ago.
I don't know if any of you are web developers or if you know Kubernetes, but basically it's a Google thing where you have your server in a node, and if a lot of people go to your website, you can create another copy of your website so it can handle the load better. And if you noticed, Printables went down for an hour or two in the past week, and we moved it to Kubernetes, which is this thing I'm talking about. So what we can do now is, if a lot of people come to Printables at the same time, we can handle the load, so it will be always fast. And also, if we want to do an update, we don't have to do the maintenance page and then start up the new website. We can just start a new node with the new version, kill the old one, and do this seamlessly. So you are browsing Printables, and you see, the old version, and then suddenly you're getting data from the new version, and there's a new feature, and the site didn't even go down. So I think in the long run, this will be really nice. So that's like...
I found out about this because I went to log into the admin panel. I'm like, the admin panel doesn't work anymore. What's going on? They're like, oh, yeah, we changed.
Yeah, so sometimes, we work on something for a month and you don't really see a change, but very often it's something like this. Or for example, for the dark mode, what we did is we took all the colors from the entire website, instead created variables for the colors, and we now have a palette. And you can switch to the dark mode without any reload. You just press a button and it goes into dark mode because it just replaces the palette, all the variables into dark colors, and then so you can make a little disco by pressing a button, and Printables is just going dark mode, demo, dark mode, demo, and it just goes like this.
Chrome extension.
Yeah, something.
Chrome extension that just does that for you.
No, you don't need an extension.
I'm saying we could get a Chrome extension that just
all the time
while you're on.
Yeah. So that's just some random features that we are adding that are maybe not that visible, but there's always something happening.
Question for Mickey.
See?
Oh, no, you're not done yet. Get back up there.
Can of worms.
Nope, you put a dev on stage, and we're going to keep him there for at least 5 minutes.
No. You have anyone who has any further questions for Mickey, you got to wait till he gets back to his seat and then ask again. So he's got because we're making Nick run.
Yes.
Like he doesn't stay this.
Okay, so Mickey, for April 1st feature, new color palette, disco mode.
We were thinking about letting you unlock some color schemes with like badges or something like that. So.
I mean, hey, like you guys, it's all variables now.
Yeah, we can do that. Yeah.
Thanks.
I told Joe earlier today, just before this, that we should release dark mode as the April 1st this year, except when you clicked on dark mode, it just made the screen entirely black and you couldn't see anything. And then on April 2nd, we can release real dark mode. Any more questions, especially on this side? No? No? All right. Thank you, guys. We're probably over time, but that's why they made us last. Really appreciate you guys. Again, the reason I'm here is because of you guys. So keep being awesome, and we will keep making a community that you deserve. Thank you very much.